Hello everyone, welcome to my channel. I hope you guys are doing well and enjoying with my video. So today's video is also from the Python playlist, and today's video is very much important for aspiring data analysts and data scientists, because today we're going to talk about the Pandas, which is the most important and popular module in data domain. Whenever you want to manipulate any data, you want to perform a EDA on the data or a kind of analysis on the data or data wrangling, the Pandas library are most important to perform those activities. And today we'll understand the Pandas. So from today, your data scientist or data analyst journey in Python started. Yeah, of course, whatever we have learned, those are also important to understand today's video or the future videos. But from today, your journey as in the data domain get started with this video. So without any delay, let's start the video and understand the in-depth Pandas module. So perfect. I have created Pandas IPUA file, and here I'm going to write all the codes, and I have also created some of the data to perform those EDAs or to understand the module of Pandas. So I will push this code to my GitHub, and I'll give the link into description. You can download the data as well as the code, and you can practice along with this video whenever you are watching. So let's get started, guys. So the question is over here, what is Pandas? So Pandas is open source module available in Python, which is used for the data analysis, manipulation, and data cleaning as well. It is fast, flexible, and very much important module, I would say that. It returns the data in form of data frame and series. So we'll understand what is data frame, what is series in detail over here. So now the question is how we can start. So as I said that Pandas is the one of the module, or you can say library in Python. So first we need to call that library or module on our existing work notebook. Then only with help of that we can perform some of the tasks. So how will you call that? So you write over here import Pandas as PD and just enter. What does it mean? That you are importing the Pandas library and you have given the name, a short name to that as a PD, like alias. You can give any name to that. That's up to you, but industry standard is that whenever we call the Pandas module in our working directory, we give the alias as a PD. PD is over here is a short name, guys. Okay, like someone having a name, let's say in school Krishna, but at home they are known as a Krish. So that's a, I would say, a short name for the Pandas over here. Okay, so now how we can import this? Just like import Pandas as PD. But if you are getting some, I would say, error, then what you can do that you can just go to the terminal, or if you are using the Jupyter notebook, Anaconda Jupyter notebook, then you can write over here pip install Pandas. It means that it will install Pandas module in your terminal, or you can say the environment. So right now I'm using the base environment. So whenever you are installing, let's say, Anaconda package, in that this Pandas is already available, no need to install. But whenever you are creating any virtual environment, in that case you need to install this Pandas library or module. Perfect. So and if you are working in if you have downloaded the Anaconda in your system and you are working on the Jupyter notebook of Anaconda, or under the VS Code you are working on the Jupyter notebook, I guess you will not get any kind of error with this. If you are getting in the VS Code, then come to this terminal and over here write pip install Pandas. Okay, but I'm not getting any error, so I'm not going to install this, because you can see the green check over here. It means that I am able to successfully import this module in my this working cell. Perfect. Okay, what we will do next? So we will create the data frame. What is the meaning of data frame? As I said at the beginning, that the return of your module Pandas is the data frame or series. So I think I have already given the definition, but here you are. So the question is, what is Pandas again? Panda is the open source library that is used for data manipulation and data analysis. It provides fast, flexible, expressive data structure. It returns the data in series or data frame that is similar to the label, relational and tabular data. It means that when you know the Excel, right? You very much know what is Excel and how the data is in Excel. So data frame is similar to that. You will understand that in just couple of minutes. So what I'll do that I have one over here dictionary. I have this dictionary. I will take this over here. Okay. So now what are things I have in this dictionary? I have a one variable data. Under that I have a name key, and under the name key we have a list of name. Perfect. Then we have a salary as a key, and we have a list of salaries. We have a age as a key, and I have a list of age along with that. And if you see the number of this age, salary and name are same. So if you count 1 2 3 4 5 6 over here, right? And over here also salary will be 6, 1 2 3 4 5 6, and age is also 3 and 3 6. Perfect, guys. Now I want to create a data frame out of that so that I can perform some of the data analysis on top of that. So what could be the code over here to create a data frame from the given dictionary? So what I'll do over here, I'll take df1 variable, that is data frame in short. Then over here I'll write pd dot data frame. Okay, pd dot data frame, and then over here I'll write data. But I have not executed this line of code, so I'll execute this first, and then let's print this data also, so you will have some sense that what kind of data we have. So this is data we have in the dictionary. As soon as I have created over here pd.data frame, pd means I am calling this pandas pd. Okay, and from there there is a one I would say method data frame. So I'm calling this method and I'm passing under that this data. So what it will do, that it will create a data frame out of this data. Now just run this cell. You just run this cell. Then now just try to print this df. You will get the data in form of data frame from the dictionary to a data frame. So now the question is, what is this data frame? How do I know this is a data frame? So if you write over here type of df, you understand there is a pandas core frame data frame. So data frame is nothing but it's a combination of rows and columns similar to the what Excel, and it has an index also, inbuilt index. So in data frame index start with the 0. How many data we have? 1 2 3 4 5 6, and index 0 to 5. So name is one of the column, salary is one of the column, and age is one of the column. And under the name column we have all the names. Under the salary we have all the salary. Under the age we have all the age over here. Perfect. And this way you have the rows. So how many rows you have? 1 2 3 4 5 6. So this data have a 3 columns and 6 rows, and this is the data frame, guys. Perfect. Very much clear how is data frame and why we are converting the data into data frame, because maybe we want to perform some of the data analysis, some of the EDA top of that. So once your data is in data frame, it will be easy for you to perform some of the EDA, exploratory data analysis, or you can say data analysis top of that. So that we'll see once we'll understand how and what are the method we have and what are the data we can convert into the data frame. Then we'll perform some of the analysis top of that. Perfect. So very first one was I have created the data frame using the dictionary. The next will be using this list, guys. So I'll copy this list from here and I will paste this over here. Perfect. Now let's run this. Now let's create a data frame out of that. What you will do for this? So you will write over here df1 equal to, or first let's convert that data into the data. What I want to do, that I want to create a list of tuple. So you will understand what I'm trying to do over here. So I'll write over here fruits data fruits data equal to a list of JIP. I think I have already explained what is JIP and how it performs, right? Under this, I'll pass this fruits. Perfect. And then I'll pass this price, guys, and enter. Then now let's try to execute this fruits data over here first. So we have a, see over here, we have a list of tuple and each tuple have their fruit and price. Now df1 equal to pd dot data frame, and over here you just pass this fruits data. Perfect. Now execute this. Now you just try to print this df1. So you have a apple and you have a their price, but column name we are not getting. Why? Because in this fruits data we don't have a columns, right? That's why we have not received got the column name over here, and by default it is 0 and 1 is the column. So what we can do over here, we can pass the our own column name over here. So what I'll do over here, I'll write over here comma columns equal to, in the list you provide fruits. The first is the fruits and second is the price, guys, right? Then now let's try to execute this. So you have a fruits and price. Perfect, guys. What I have done, I have a two list. From these two lists, I have first created the tuple of the list where we have a each fruits and their corresponding price in individual tuple, and then I'm using that under the fruits data into the data frame to create that. There is a one more method of doing that. How we can do that? So what I'll do over here, I'll take df3 equal to pd dot data frame. Okay, I'm not passing anything to this. I'm just creating an empty data frame. This is creating basically what? Empty data frame, guys. Empty data frame. Perfect. We have created the empty data frame. Now if you check the type of your df3, you will understand this is a data frame. And if you try to print this df3, you will understand it is empty. Now I can create the data. I can feed the data into this. So what I'll do, df3, and I'll pass over here, let's say a name, not name, sorry, fruits. Fruits equal to, I can pass this fruit, which is over here, this fruits list. Perfect. And then again df3, and over here I can pass a price equal to, I can take this price, and I'll easily pass to this. Perfect. Now let's try to print this df3. So in the df3 you have a fruits and price. Perfect. So there's a two way of creating a data frame from the list. One is that you, whatever the list you have, that convert into the JIP. After converting into the JIP, you just create the data frame and pass that list of tuple and pass the column name, custom column name. Perfect. Other is that create one empty data frame, and under the empty data frame you just assign the what, each list corresponding to that, and you just define that also as a column over here. It means that I'm defining the column and passing this value to this fruit value to this column. Over here again I'm defining one column price inside the df3, and I'm passing this price to that column. Perfect, guys. Now what I'll do over here is I will create one function. I'll create one function that will take n number of list to create what? To create a data frame out of that. So we want to create a function for that. So let's say def is the keyword which is used to create any function. Then list to data frame. Perfect. Now we want to pass the n number of list to that. So I'll use the asterisk and then list. It means that we can pass n number of list to this. Now, once we pass this over here, then we have to check first all the list, whatever we have passed, are having a same length or not. If the length is not same, it will create a problem. How? Let's see over here. What I'll do over here is I will remove one of the price from this. So in the fruits list, I have a 1, 2, 3, 4, 5 elements. In the price list, I have a 4 elements. Now execute this. After that, execute this. After this, execute this. So you have a 1, 2, 3, 4. Okay. By default, it has taken the element based upon the lower, I would say, index or lower list element. But I don't want this. So because it's already 4 now, if you try to execute, it will not throw any error. Perfect. But if you try to execute this part, let's see we have any error or not. It will have an error. See why? Because in the fruits we have a how many? 5 elements. If you see over here, 3 to 5, and the price we have a 4. So once you create the empty data frame, after that, if you assign your list to that, you will be in the trouble. And the trouble is value error. Length of value 4 does not match the length of index 5. It means that any of the list are having a less length. Both are not same. Similar way, if we are trying to pass over here, or if we are trying to create a function that take n number of list and convert that into what? Convert that into a data frame, we have to check whatever the list we have taken, all are having a same length or not. So what I'll do over here, I'll write first over here, try. We need the exception handling as well. Why? Because we're not able to handle the error. Then I'll write over here. So now what I want to do that whatever the list has been shared, all the list length should be same. So I'll write over here length iterator equal to I want to check the length of each of the list. So I think the map is the perfect function over here. So I'll create a map. In that, I will pass that function into each and every list to check the length of that. And I'll take the length of each and every what? List. Perfect. So I'll write over here list. I want the list because I'm using the map, guys. So under the map, I need the first is the function. So lambda of x. Then next, I want the len of this x. And over here, I want the list. This list, which is over here. So what it will do this, this x of len of x will go each and individual list and check the length of that. And it will create the list of the length. Perfect. So now over here, just write, I'll need to import the logging also. Import logging. Okay. And logging dot basic config and over here label equal to and taking, let's say, info. Perfect. So over here logging dot info, and I'll pass over here length of each list is, I can pass over here, let's say this length iterator. So it will show you that what is the length of each and every list that has been passed. Now what I want to do that I want to use the I want to remove the duplicates out of that. What does it mean? Why I want to remove the duplicates? Let's say that I have provided the 3 list, and all the list having a 5 elements. So this length iterator will have a list of 5 comma 5 comma 5. Perfect. Case 1, I have provided over here how many? 3 list of 5 length. So this length iterator we have a 5 comma 5 comma 5. Perfect. So what I want to do, that I want to remove the duplicates. Once I'll remove the duplicates, it will left with the 1 element, that is 5. Perfect. So after that, I will check if the length of that list is more than 1. It means that it has a more than 2 elements, 2 length. And when you have a 2 length, in which scenario you will have a 2 length? Whenever you have a list with a different length. The case 2, let's say, if you are not understanding, we have a case 2. Case 2 is providing a 3 list. One is the length is 5, another is a 4, and another is again 5. Okay, so under this, what will happen? You will have a this length iterator list. In that you will have a 5 comma 4 comma 5. Perfect. And whenever you remove the duplicates, you will left with a 5 comma 4. And now if you check the length of this, it is 2. It means that you have a length iterator 2 different values. Perfect. You have in the length iterator you have 2 different values, means one of the list having a more than or less than, or all the list whichever has provided has not same element. Perfect. So that is what I want to check over here. So what I'll do over here now, I will take one x variable, and then I'll pass into the set of this length iterator. What is the behavior of this set? I think I have already explained you. Set contain only the unique values. So if we are passing 5 5 5, then x will have only 5. If we are passing 5 4 5, this x will have a 5 and 4. Perfect. Now what I'll do over here, if the len of x is not equal to 1, if the length of x is not equal to 1, and or before that, let's do the logging also. Logging.info. So it will give you some of the traceability to you, and the total element available in the x after removing the duplicate. You just write over here length of x after removing the duplicate is x. If it is not equal to that, then what I'll do over here, I'll raise the error. Which error? This value error, which is over here, this value error. Okay, and I'll write over here value error, and write over here length of the given list is not same. Else what you will do, you will do the zip of your list. Once the zip of list is done, next you will create the data frame. So result equal to pd dot data frame, and you will pass under this let's say this is the zip, and list, what you will write over here, data equal to this zip, and it should be list also, because you are using the zip, so there should be a list. I think you know very well, because you haven't already watched my zip videos. Perfect. Now I'll take this data and I'll pass over here. Perfect. So, and after that I'll return this result, except exception as a e, and over here logging dot info and just pass error type over here ERRO error and info is str of e. This is one of the method of writing the log, guys. So what I have done, if you have not understood this line of code, that first I have defined this, or let me first run this code, guys. It's very much important. I'm getting some error. What is the error? Info is not defined. There should be actually logging.info. Logging.info. Now execute this. Executed. Perfect. So I'll test this using a 3 list. So I'll create one cell over here. I'll copy this and paste over here. Then I will call this list data frame, list to data frame. It should be actually list to data frame. Execute this again and take this from here and pass over here, and you pass name comma age comma salary. Perfect. We have a problem now. The problem is length of the each list is length of iterator. Okay, let's debug and do this. Right over here F first. Right over here F first. Now execute this and again execute this. It's 4 comma 4 comma 4 duplicate. After removing the duplicate, you have only one element. That's fine. Zip of list, and you have a list over here. So let's try to use the logging over here also. Logging.info, and over here is your data. Here is your data after zipping, and you pass over here this data, and here it should be F. Now try to execute this and try to execute this. So whenever you are trying to zip this, it is not able to zip properly. See, there is some problem over here. And what is the problem? Okay, this list is having a 3 different lists. So I think I need to use over here asterisk. So once I use the asterisk, then it will be able to zip properly. So now execute this, see, Rahul 20 and their salary means a name, age and salary, name, age and salary, name, age and salary. Perfect. So I'll take this as a, let's say df4 equal to, execute this and now take this df4. So you have a this one. So what you can do over here is, so first we'll understand that how this code is working, then we will assign the columns to this. So let's go to our main code over here. So I have created one function. So now onwards, whenever we will create any kind of function, we will define that using the logging and exception handling, because in the production grade it is important that there should be a logging and exception handling. So I have already covered those topics. So we will always, whenever we create any kind of function or class, we will utilize exception handling and logging. This way you will also have a habit of writing a code in production grade, including the logging and exception handling. So over here I have not I would say that created a complex logging. What I have done, just basic, I have set the config and label equal to logging.info. If I am setting the logging label as an info, it means that I will able to log info, warning, next error and critical. Perfect. So I think you understand this point. After that, what I have done over here, I have created one function with the def keyword. Then I've given the name of the function list to data frame, and I am over here using the asterisk with the list as an argument. What does it mean, this asterisk? Asterisk means that I am able to pass n number of input at the same time. So I want to pass the list over here. So that's why, or how many lists, maybe 2, 3, 4, 5 or n list. That's why I'm using this asterisk over here. Perfect, guys. Now What is the purpose of this? I would say data frame. Sorry, this function. The purpose of this function is I want to take n number of list, but I want to create. What do you want to create? I want to create the n number of, sorry, from that n number of list, want to create a data frame. So to create a data frame, it is important that all the lists should have a same length, because if you not have a same length, it will create the value error, guys. Perfect. So for that, let's say if I'm passing 3 lists to this, I will check the length of each list. So same thing I'm doing over here. I'm using this map function. What is the functionality of map? The functionality of map is that it will apply the same function on each and every individual element, or you can say iterator. So over here I'm passing this list, which is having a 3 different list, so or 3 or 4 or n different list. So this will check the length of each list, and it will create the what? It will create one list of the length of each list, like this. If you see, it will create the length, one list with the length of each list which I'm passing over here, like this, guys. Okay, so or if you want, I can just pass this also over here, equal to, let's execute this, let's execute this. So length iterator will have a 4 4 4. Why? Because we are passing a 3 list, and all the list having a how many? 1 2 3 4 elements. That's why it is having a 4. After that, what I'm doing over here, I'm passing that into set. What is the main characteristic of a set? It will remove the duplicates. Perfect. So if I'm passing a list which is having over here, let's say 4 comma 4 comma 4, then this set will have only output as a 4 1 4. Perfect. 1 4. So if you see over here, it is having only 1 4. That is your x. This x equal to, execute this again, execute this again. So x will have only 1. Then I'm checking if the length of that x is not equal to 1. If the length of that x is not equal to 1, then raise the value error and length of the given list is not same. Otherwise, if it is equal to 1, then I'm converting that into a zip of list, means tuple of a list, and that I'm passing into the data frame to create the data frame basically. So now I think you already understand this. So we have this 3 list, and I'm passing directly to this, and it is creating one of the data frame, but we don't have a column. So what I'll do over here, dot columns equal to, I'll pass over here, let's say first is the name, second one is the age, and third one is the, let's say, salary. And now df4, we have this. But if you want, we can also pass over here this name, I would say column name, and in the list, in this function itself, it will assign that what? Column name. So over here we can pass one more list, and that list will be as a name, guys, name of the column, and that will be used over here to just assign the name to the column name, I mean. But I'm not going to do that. You do it and share the screenshot with me on LinkedIn or maybe in the comment. Now what I'll do now is I will, let's pass one less element into the edge and check what will happen. As soon as you pass this, you getting the info root type error. Info is length of the given list is not same over here. So it should be error, I think, not the info, because error it should be now, because it's going to give the error. So it should be error. So over here, see, the first one is the length of the each element is length iterator 4 comma 3 comma 4. So one of them having a less element, and the x equal to 3 comma 4, which will basically make this true. This will make this true. So if the length of x not equal to 1, then raise the value error, length of the given list is not same, and that has been handled by this exception. And you are having this over here error root type error, info length of the given list is not same, which is over here. Length of the given list is not same. Perfect, guys. So you understand now how this function is basically working. Now, so till now we have understood how to read the data using the dictionary and list. Now we'll understand read the data from the Excel. Read the data from Excel. So in this case, what I'll do over here, we need the Excel file. So I have already kept one Excel over here. If you see, that is patient data Excel, this one. But we cannot open this over here, right? So what I'll do that, I'll open this Excel file first and I'll show you that, and then I'm going to open use that Excel into the code. Perfect. This is the Excel which we have of the patient data. In this Excel, if you see that we have a two sheet, a patient 2025 and patient 2026. And in 2025, we have a patient ID, patient name, age, email, policy number, and policy type. If you check in patient 26, we also have a same patient ID, name, age, email, policy, and policy number and policy type. So both the I would say the sheet having a same data, only difference is that this is the 2025, this is the 2026. So I want to use this data into the my code. I want to read this Excel first. So how we can I would say read over here. So I'll first write the patient file path equal to, so it's already in this folder. So this is the Excel. What I'll do, I'll right click, and over here we have a copy as path, copy path, and I'll paste it over here. Perfect. After this, what I'll do, I'll use over here, let's say patient data equal to pd dot read, and over here Excel, and then you pass this patient file path and execute this. You are getting the error. So this error means this Python code is not able to decode this forward slash, guys. So what I'll do over here, I'll just use R this. This R means it will able to handle this all this slash whatever you have in this code. The other method is that you change this into double slash, but it will take time because you have a n number of slash inside this. So better option is you just remove this and use the R over here. Okay, execute this and see it has been executed. Now let's run this over here and you have this data, but you are not sure that this data is from your I would say 2025 or 2026 because we don't have any identifier in the data. So what I'll do, first we'll set the identifier and then we'll check whether this data is from my 25 or 26. So what I'll do, I'll again open the Excel, guys. I'll open the Excel, and in this Excel I will write over here year, and over here it's 2025. So copy this in all. Perfect. Now let's save this and go to the next, and over here also create one new column, that is a year. Okay, and over here 2026, and copy this into all the row. Perfect. Now just cancel this and run this again and run this again. So you are only having a 2025 data. Where is 2026 data then? So it is very important. Make a note. Whenever any Excel having a more than one, I would say, sheet, and if you are directly using that path to read the Excel, the Python Pandas module will read the very first sheet and it will ignore the rest all sheet whatever is available in the given Excel. I hope it makes sense. Now your question will be, then how we can read all the data? How we can read all the data, like all the sheet? So for that there is other code. So we already have a path over here. So what I'll do over here, I'll write over here patient data, same patient data equal to, or patient data, I'll not write over here, I'll write the Excel file. Excel file equal to pd dot excel file, and pass over here your this XPath. Perfect. Now this Excel file dot sheets, I think it's sheet name. So in this Excel we have a patient 2025, patient 2026. Now just read the patient 2025 here, and next cell you read the patient 2026 over here. So patient 2025 equal to pd dot read Excel, and over here your Excel file which is already having your complete path. So pass this and comma sheet name equal to, you pass this. Make this data, so you should not have a confusion. So I'm creating one variable patient 2025 data equal to pid.read Excel file. This Excel file I'm passing over here. Then I'm passing the sheet name equal to this sheet. And what I'll do over here, I'll just copy this part from here to here, and over here I'll use 2026. So this way you will be able to read the individual sheet from the given Excel. Now try to see the data in what are the data are available in 2025. You have this data, and next try to use this to understand what the data are available in 26. So both the sheet we have already read over here. Perfect. Next, read the data from the CSV. So let's say CSV file path equal to take this CSV path, copy the path. Here is the copy the path and pass over here and use R again. Then CSV data equal to pd dot read CSV, and over here the CSV file path, pass over here, and then CSV data. You will have all the data over here. So we have seen till now, read the data from the dictionary, read the data from the list. We have also created the custom function to pass n number of list and read that data. Then we have also read the data from the Excel to different sheet, read the data from the CSV. Now next is read the data from JSON. So these are the important, I would say, file which is important to understand how we can read the data from this. So JSON file path equal to what I'll do over here, I'll take this JSON. We already have this. So copy the path. Now pass over here under the inverted comma and then use the R over here. Next, what I'll do over here, let's say pd dot read, and over here JSON, and pass this JSON file path. Oh, I did a mistake. Control Z. JSON file path, and you can read the data from the JSON as well. So in this video, guys, we have seen how to read the data from a dictionary, then a list, created a custom function to create to read data from n list, and then fourth, Excel file. Why am I writing Excel file? Means we have a sheet right over here, sheet specific, then over here CSV, and in the sixth we understand the JSON. So these are the topic we have covered in this video, and I'll stop over here. In the next video, we'll understand the pandas other functionality, how we can perform the data wrangling or the data analysis using the pandas. Perfect, guys. So I'm using the same IPynb file which I was using the last video. So now we'll understand in detail how we can do the data analysis and what are the, I would say, EDA exploratory data analysis we can perform on the pandas. So in the last video, we were using the patient data, right? In the patient data, we have a two, I would say, seed 2026 and 2025. So I'll take any one of them because both are having a same data. So I'll take this one, let's say. Perfect. So let's copy this over here. And we have all this. Now what I'll do that I'll make this short because this is the variable name is quite long over here. So it will be whenever we write a code, we have to write a lot of, I would say, words over here. So I'll convert this into df equal to patient 2025 data. Perfect. Now we have this data over here under the df. The very first one is I want to know how many row and column we have. How many rows and columns do we have? So for this, we'll write df dot shape. So once you write this df dot shape, it will show you that in your data you have 1,000 rows and 7 columns. So if you check that, 1 2 3 4 5 6, but it's showing 6 only. What is the mistake? So I think you understand, we have added one more column, that is year. That's why it is showing the 7 column. If you check 1 2 3 4 5 6 7, perfect, and it has 1,000 row. If you see over here, it is mentioned. So similar way with the shape, you can find out there are thousands of rows and 7 column. Now if you write df dot size, so it will show you the size of your data. So it has basically 7,000 KB. Perfect. Now the other one we have, I want to see the different, I would say, overview, or you can say the data types of my data frame. So what I want to show, what I want to see the data types and overall view of the data. What does it mean, overall view? Just let me write, then you will understand. df dot, I'll write info. As soon as you write info, it should not be this, it should the function. So I need to use the parenthesis over here. As soon as you write the df dot info, you will see that it will show the class pandas core frame data frame. So it is a data frame. Range is range index 1000 entities 0 to 999. It means that there is 1,000 entries or entities, you can see a record, whatever, and the index is basically from 0 to 999. Data column, total 7 columns are there, and the column name over here and none count. So in the each columns you have 1,000 records. And why it is showing thousands records? Because none of the column having any null values. Null means empty. We don't have any empty values in any of the columns. Perfect. Now the data type, the patient ID is integer, patient name is str, object means str, a string, guys. Okay, age is also what? It's an integer. Again, email, policy number, policy type, and these are the string, and your year is basically integer again. Memory uses, how much memory it is using, it is also showing. So this is the overall view of your data. I hope it makes sense. Now I want to see top 5 records, and this question has asked in one of the interview. The company name is TCS. So I think back in 2020 of 2020, I'm not sure, I think 2024 or 2023, not 2024, I guess 2022. Yeah, 2022 I was giving an interview, and in the TCS they asked me this question. They asked me to create one data frame using the dictionary, and then they asked me to show me the top 5 records from the given data frame. So how will you see, or how will you write a code that this should show only the top 5 records? So for that, I'll write df dot head. So as soon as you write df dot head, it will show the top 5 records, 0 1 2 3 4. If you count 1 2 3 4 5 records, right? All the columns, but only 5 row. Similarly, only bottom 5 records. How will you do this? So df dot tell. If you write df dot tell, it will show you the bottom 5 records. Perfect. Now the question is that I want to see 20 records from the top. So how will you do this? It's very easy. Df dot, you will write head, and over here 20. Done. So here is a 20 record of top. Now you want to see the data from the 21 to 30. What you will do? Can you write this df dot head 21 to 30? It will not work, because under the head you cannot pass like this. Or if you can think like I can pass the comma, no, or I can pass the list, no, this will give the error. You can only pass the 20, 30, 40, 25. It means that from the top to 25. If you use the tail over here instead of head, tail, tail, then it will show you the bottom, from the bottom 999 to the top 25 records. Perfect. So this is how you can see the top 5 records, top I would say bottom 5 records, and 20 records, whatever you want to see. Next, that I want to get only the column name. I want only column name, columns name. What you will do for that? Df dot columns. As soon as you write this, you will get only all the columns whatever is present in your data frame. Next, if I write df dot describe, it will give you the statical value of all the integer columns. Only the integer column, not the str. So patient ID was a integer column. So in that it's showing the count, it's 1,000. Mean, what is the average of that column? But there's no meaning of that. Patient ID is just the ID. It's like a roll number. What is the meaning of finding the average of your roll number? This makes no sense. But as it is an integer, it is trying to perform some of the statical, I would say, operation. So basic statical operation like a mean, standard deviation, mean, 25 percentile, 50 percentile, 70 percentile, or maximum values what you have in this. Okay, so just if you go to the age column again, you have a thousands of count in that age column. The mean of the age is 48, standard deviation is 18.36, minimum value, the minimum age in your data is 18, the maximum is 80, the 25th percentile is 32 age, and 50th percentile is 48, and 75 percentile is 63 actually. So these are the some, I would say, basic statistic which is you can get on the your integer columns using the describe. Perfect, I guess. All set. Now you are enjoying this. Perfect. Because see, pandas is one of the easiest, I would say, library where you have to call just some of the modules function. It's basically a function of that module, and then, or you can say method of that module, that will help a lot you to perform a data analysis on the given data. Next, let's say that I have this df, right? I don't want to get all the columns. I want to get only one column. So I can just write, let's say, dot, and I want to get age. So I'll write over here age. So I'll get this age over here. But this is not in the data frame, right? This is not a data frame. So what kind of this data, whichever I'm getting over here, what kind of data is this? So if you try to find the type of this, type of your this df.age, it is series. So now what is series? I think in the previous videos I have explained that pandas return into two data type. One is the series, one is the data frame. Data frame is similar to the Excel, where you have a multiple columns and row combination. In series, what is series? Series is nothing but a one type of data type which is having a only one columns and label is index basically. So series is a type of data type which you have one dimension labeled array. It means it has a two main part, value and index. So as I said that series is a type of data type in the pandas which are having a one columns along with that one index. So that is called series. That's why whenever you want to get only one column from the data frame, you will get the series of that. So now let's one more question over here is how to create a series from the list. So let's say that we have one fruits, right? We have one fruits. It's, I think F is capital. Perfect. Now we want to create a what? Series of this fruit using the pandas. So what I'll do over here, I'll write over here, let's say series s equal to pd dot series, and you pass over here fruits and then s. So you have a series of this. As soon as we also have over here a price, right? If you see, we have a price. If you pass over here price, it is actually it should be this one. If you pass the price, it has 4 actually. Okay, then use append. Let's say make this append, let's say 30. Now it will be equal length. Why I got the previous error means because the length of your fruits and the price are not same. Now it is same, right? So what I'll do, I'll use the fruits and price both in the pd.series. Let's see what happened over here. And now it has executed. Now check this. So your price is working as an index over here and your fruits is working as a column over here. But if you want, you can pass this as a index. So over here you just write this and you have a, see, apple, guava, plum, all these are fruits are basically index over here and price is your column over here, because in the series you have only one column and one label, that is index. So what is series? I think you understand now. Series is basically a data type in return of pandas which have a one dimension, that is one column and one index. Perfect. Now come back to our data frame. So let's remove this part from here and df. Okay, so we have this. Now what I want is I want to get only one column. So df dot age I can write and I can get this. I think this is age. I can get this, and this is the series. Other way of writing this is df of under this age, and you will get this also. But if you write under the 2, I would say this square bracket, then it will be in the form of what? Data frame. Now if you check the type of this, it will be a data frame because I have passed under the 2 square bracket. And if you pass under the 1 square bracket, it will be a series, guys. Perfect. So now if you want to get more than 2 columns, then what you will do in that case? So we'll write over here, let's say df dot columns first to get all the columns detail, guys. Perfect. Now what I want, that I want the patient name and age both into a one, I would say instance. So at one instance, I want the patient name, age both. So what I'll do over here, df, and over here write this patient name. Always try to copy from this result of your columns, because sometime it can be typos also, or you may get the error. So it's always good to copy the column name and paste over here. Now enter this. You are getting the error. Why? Because you need to pass the column name in the list. So this is what you have done over here. Now you use the another, I would say, square bracket this. So over here you have a patient name and age. So I'm passing, if you have a more than one column, always pass that into data frame in form of list, and then use the square bracket, outer square bracket for the slicing. This is called the slicing based upon the columns. If you want more than two, then you just add over here. Let's say you want the policy number, so add this policy number over here. Perfect, guys. Perfect. Now, so this is how you can slice your data based upon the columns. Now, if I want, let's say I have this data, and I want from my 20 to 30 or 20 to 31, I want the records with all the columns. What I can do for that? So I'll write over here, get all the columns along with 20 to 30 rows number. So for that df.iloc, I'll use, what is iloc? You will be surprised with that, but I'll explain it. Just give me a couple of minutes. Iloc, and then I'll write over here 20 to 31 and comma and all the columns. So you can see, you can get from the 20 to 30 and all the columns over here. Now the question is, what is the iloc? So iloc is nothing but the index location, and the syntax of this, the syntax of your iloc is first iloc data frame dot iloc, and then range of rows, comma range of columns, that you have to pass over here. So range of column I have passed from 20 to 31. Why 31? Because you know that the higher one get omitted, it will get ignored from the list. You understand this, right? So 20 to 31 I have given because I want to be printed over here as a result 20 to 30. That's why I've given here 20 to 31, guys. Perfect. And then I have given this over here. It means that I need all the columns, guys. That's why I've given over here only this double dot. So this is how you can get all the data from 2030 with all the columns. Now the next is, I want only patient name and policy type from 15 to 25. So let's write over here, get records from 15 to 25 index for a column patient name and policy number. So what you will do for this? So I'll write over here again this df.iloc, and over here 15 to 25. So 15 to 26 I will write. Next is patient name and policy number. So patient name is this and policy number is over here. So I should get, this is 0, 1, 2, 3, 4. So this is 1 and this is 4. Policy number, right? Or let's make this policy type, not policy number, because you will not see anything in the policy number, right? So that's why I need the policy type. So patient name and policy type. So patient name index is 1 and policy type index is, I think, 0, 1, 2, 3, 4 and 5. So I'll write over here 1, 5, and we are having a too many index. That's right. So let's pass this into the one list. So this is for your columns and this is for your rows. Why I have passed into the list? Why? Because if I write, let's say over here, if I write over here 1 dot double dot 5. It means that 1 second, 1 colon 5. It means that I want all the data from 1 to 5. So see, 1 2 3 4 means it will get omitted the highest one. So I have taken all the index from patient to policy number, but this is not what I want. I want only this and this one. So if you want to pass both, then you have to pass in the list those index number, and you have the data from 15 to 25 with policy name and policy type, guys. Perfect. Next question will be that, let's say we have a thousands of records, sorry, thousands of columns, and if I want any specific columns, then we have to first count the index number of that column, and then we have to write it over here. It is a bit tedious task, right? What I'm trying to say over here, let's say I have a total 20 columns over here, and I want as a result 15 to 26, that is row number, and column position I want 17 and 19. Then how will you count if you have a 1 to 20? How will you count that which column number is falling on the 17 and 19? So you have to manually count that, but this is tedious task, I would say that. Then what is the other way to achieve that? The other way of achieving that is df.lock. df.lock, and you pass over here this, let's say 15 to 26, same row I want. In the column you pass the name of the column. So let's say I'll pass this patient name, comma, and policy type. Policy type is okay. Make this and now execute this, and you will get this. Now your question will be, what is lock? Now I am get confused. So lock is nothing but location, and the syntax of this data frame dot loc over here, range of rows, comma, in the list, name of the columns. So with this, it will be easy to slice your row and column together, guys. Perfect. Next, let's say that I want to or let's get first data over here, df. Now next I want the data from 45 to 65 records for policy, let's say patient name and email, only these two. So what I'll do over here, df.loc, I said 45 to 65, so 66 I will take. Next I want the patient name, so I'll copy this and I'll paste over here. Perfect. Next, what I want this email, so I'll take this email and execute this. So you have from 45 to 66. It should not be 66, I say 65. So okay, let's take the 65, because it take what happened to the first one? Let me see over here. I have given 26. Okay, it is not omitting the highest one, so you can take this till 25, guys. This is also one of the interview question has been asked in the TCS. What is the difference between iloc and lock? So iloc is index location, where we pass the row range and column range to slice out the data frame, and the lock, that is location, where we pass the index, sorry, a row range along with that column name. So that is the difference between these two. And in the iloc, in your iloc, I think there's a mistake over here. Okay, this is a mistake, guys. I guess it is not a code, so it is not able to execute this. Okay, in the iloc, the highest range get omitted, but in the lock, highest values not get omitted. So these are the difference, guys. Perfect. You are doing good now. Okay, so next is how to rename, rename the columns. How to rename the column? Let's say that df dot columns I have. Now I want to convert this age as a patient age, or age as a patient age. So what I'll do, df dot rename, and over I'll pass columns equal to then a dictionary. In the dictionary, the first one should be the old name of the column. The old name of the column is age. Then that will be key, and the value will be new name of the column. So the new name of the column is patient age is the new name. And as soon as you do this, execute this, you will get as a patient age. But as soon as you execute in the next cell, it will be as it is, guys. It means that for this instance, the age has converted into patient age, but it has not changed the name into the schema. For that, you have to pass over here in place equal to true. It means that if you pass in place equal to true, means it will change for forever. It will go to the schema and it will change the name of your age column to patient age. But if you don't write this, it will change only for this instance. I hope I'm making sense. Now, as soon as you execute this, and it has been executed. Now, if you try to execute this, say it has been changed to patient age. So in place equal to true is important if you want to change the name of the column for forever. Okay, perfect. You are doing good now. Now let's say that you want to delete some of the columns, or before deleting, let's say that you want to change more than one column name. Then what you will do in that case? So let's say that I'll do it over here, df dot rename and columns equal to, I'll pass the, let's say email to the patient email. I'll pass over here. So my key is the old name email, and it should pass to the patient email. Patient, let's say email. Perfect. Next is the policy number. I want to change into policy underscore NUM. So I'll take that and I'll pass over here policy number, and over here it should be policy NUM, guys. Execute, and it is done. See, policy num, and this email is a patient email. But I don't want to change this for forever. Just I want to show you, if you have more than one column to change the name, how you can do that. You can pass over here as a key and pair value. Key will be the old column name and value will be the new column name of that corresponding name of the column. Okay, but actually I don't want to change for forever, so I'll not use over here in place equal to true. Perfect. Now we have this df. I want to, let's say, drop some of the columns. So this product patient ID is not making sense for me, so I want to delete this. So df dot drop columns equal to, I'll write over here patient ID. This is the patient ID I want to drop, and it has been dropped. But it has dropped for this instance, not for forever. If you check this over here, you have a patient ID over here. But for this instance, it is done. So now let's say that you want to delete more than one column. What you will do? You pass over here the column name in the list. So patient ID, and next let's say I want to delete the year. Perfect. So year has been deleted over here, but it will be available over here. Why? Because I have not used the in place equal to true. That's why. But as soon as I use over here in place equal to true, this both column patient ID and year will get deleted for forever. But I don't want to do that. If you write in place equal to true, it will be deleted for forever. But I don't want to do that, honestly. So I'll not do it. If you want, you can just try that. Perfect. Next, let's say that I want to find the index of my data frame. So index is from 0 to 1000. But this is the number it has. But I want to set patient ID as my index. So what I'll do over here, df dot set index set index, and I'll pass over here this patient ID as an index, and this is done. But if as soon as you check over here, this is not done until unless you don't pass over here comma in place equal to true. This will not set your index as a patient ID. Now if you check now, it is patient ID. So patient ID has converted into index, rest all is the column. So now if you check your df.sep, you will have a how many columns? Right, 6 column. Why? Because one of the column is index. Oh, my bad. 6 column. Now let's say that I have set this as a index, but I don't want to set as an index. What we can do that? So just write df.reset index, and your patient ID will become as a column. Now if you check over here, it is a okay, I should use the in place equal to true over here actually, or you can assign this directly. What you can do over here is that you can assign this over here, df equal to df.reset index. Perfect. And now if you check this, you have a 7, and just check that dot head I'll use over here, let's say. So patient ID is one of the column now. Now what I want, that I want to arrange this data based upon the patient age. So what I'll do over here in the ascending order. So the lowest age should be on the top and highest age should be at the bottom. So what I'll do, df dot short value by, and over here I'll pass, let's say patient age. I'll pass. Data frame has no attribute short value. Short, I think it's a values. Yes. See, it is from 18 to maximum. Now, if you want to make it descending order, then what you will do over here? You just write over here descending. Sorry, ascending. Ascending equal to false. It should be small. ASCENDING. Now let's try. Yes, so it has taken from the 80. But if you check over here as a df, it will be mixed. Why? Because I have not used the in place. So if you write over here in place equal to true, so it will rearrange your data forever based upon your age from highest to lowest. Now if you check this, your df, so it is from 80 to 80. Now if you want to make is ascending order, you just remove this part, and it will arrange your data into ascend based upon the age, ascending order from lowest to highest. Perfect. This is what it is. Now if you want to arrange in descending order, you write ASCENDING, ascending equal to false. I forgot the comma over here. See, this is one of the easiest, I would say, module, right? You are writing like it's not a code at all. See, it's like a plain English and some of the special character, that's all. Next, I want to see that in the policy type, how many policy types are there. So what I'll do over here, df dot or df of this policy type dot unique, and use this maybe. Then you have a platinum, you have a premium, you have a gold, and you have a basic. If you want to know the number of unique policy type you have, you can just take this over here and then you use over here n means it will give the number. So you have a 4 different type, 1 2 3 4 right over here. Get the unique type of policy data has, and over here the number of, get the number of unique policy data has. Same apply for your age also. So you can write over here dot age, and I think age is patient age. Now take the patient age dot and just get this unique. So these are the unique age you have in the as descending order, because you have arranged this in descending orders. Perfect. 18, 19, 20, 21 till 80. And if you want the numbers, so you just take this from here to this cell and you use over here n, and you have this. Perfect, guys. All set. So I have used the same IPOINB file where we have stored. We'll continue from there itself. So we already have the data frame, that is df, right? And from there we will start working and we'll understand some more analysis on our data. So we have a 3 different data based upon the policy, if you see over here. So in the data section, if you go, we have a patient data. Under this patient data, we have a 2025 and 2026 data, right? Then we have a policy data. So what we are going to do now, we are going to use those all data and we'll perform some of the analysis top of that. So on the top, I have defined the patient data 2026. If you remember from the last video, we already have that variable over here. So what we are going to do that we're going to use that one, and we will do certain analysis using that also. Patient 2026 data, we're going to use this also now. So what I'll do, let me first get this data over here and now execute this. So we have a patient data 25 in the df and 26 over here. Now we're gonna combine both the data, as both the data are same and we have only the year difference. So what we'll do, we will use to combine both the data. How we should combine this data? We should combine this data vertically. What does it mean by vertically? So let's say that we have one data over here, which is 2025 data, right? So this is the data which is 2025. Now we have a 2026 data which is over here. Let's say we have a 2026 data over here. I want to combine both, so I'll bring this over here, right? So it should be completely one data. You can say on the top it will be 2025 and the bottom it will be 2026. So I want to combine the data vertically. I want to combine the data vertically. For that, I will use one of the method into Panda that is called concatenation. Concatenation. So this is the important, I would say, concept. Whenever you want to combine both the data vertically, then we use this concatenation. It's not always necessary that using the concatenation you always combine the data vertically. You can combine horizontally as well as the vertically based upon the requirement. So now we'll understand how we can combine data vertically. So what I'll do over here is I will use both the data and I'll write over here, let's say pd dot concat. Perfect. And over here I'll take the list. Over here in the list we'll pass df comma and I'll use this patient 26 data. Perfect. And I will pass over here. Now we have to give the axis also. Axis is important. Without axis the data will not concat as per your requirement. So let's say the first trial, I'm not going to pass anything access. I'll just write pd.concat df, which is my patient data 2025 and the patient 2026 data. Now enter this. As soon as you have done this, this data has concatenated vertically. You can see over here, there is a 2000 rows are available. But if you see patient ID, name, patient age, email, policy number, policy type, and then we have over here year, age and year. Why? We already have one year over here, then why we have year again over here? And we already have age over here, then why we have age over here? We need to understand this part, guys. This is very much important to understand before starting the concatenation. What happened actually over here? So if you see the column name, let's go to the next cell and try to get the df dot columns. And you have these columns. Now take your 2026 data, okay, and try to get the column over here also. So if you see that patient ID, patient ID, patient name, you have patient age over here, but you have age over here. So both the columns are not same over here. Email and email, policy number, policy type. Here is a small and here is a year capital. So it is very much important whenever you are doing the concatenation between the two data frame, both the data frame columns name must be same. This columns name must be same. So over here, because of this age and you have over here patient age, it has created a two different age column over here. One is the patient age, that is for your 2025 data. So for 2025, if you see, you have a patient age available, but for 2026, it is none over here. Similarly, for the year, it is small and capital. So for 2025, 2026 is null, and 2020 for the 2026, you have 25 null over here. So I think it makes sense now. So what we have to do now, we have to combine. Before combining both the data, we have to make sure that all the columns available in both the data must be same. So what are the columns name are different over here? The patient age and I think year, only these two. Because if you see, there is only two column extra created, that is age and year. Rest all we have it. So what I'll do over here, I'm going to write over here the rename column code over. So I'll take this patient 2026 data, not columns. I'll remove this part and I'll write rename, and under that columns equal to the old column name and the new column name. So I'll take this old column name, that is age. So over here age, perfect, and new column name should be patient age. So I'll copy this part from here and I will pass it over here. Then we have one more, that is this year. Then take over here comma and year. Now take this year, perfect. And after that, we also need to write over here in place equal to true. Why? Because we want to change the name on the schema level, not for this instance, right? True. Done. Now let's take this patient 2026 data dot columns, and you have the column name over here, which is exactly same as your df columns. Now you perform over here pd dot concat, and you pass over here df comma and this patient data 2026. Okay, I need to pass both the data frame into one list. So now if you see that we have a 7 columns and 2000 rows. Patient ID, patient name, patient age, email, policy number, policy type, and year. Under the year, we have 2025 and 2026 data. Perfect, guys. So this is how it is. Now, I said that writing an axis is important over here, but by default, it has combined both the data vertically. It means that it has combined both the data at axis 0. What does it mean, axis 0? So let's say we'll write over here axis equal to 1. It should be comma over here. Axis, I have mentioned 1. So now I have mentioned axis equal to 1. Now if you see that we have 1000 rows and 14 columns, it means that it has added the data, both the data it has combined horizontally. How? It has combined the data horizontally. How horizontally? Like what does it mean by horizontal? It means that we have one data over here, that is nothing but 2025, and another data is over here, that is 2026. 26. So by column wise, it has 7 columns and 1000 rows, and it has 7 columns and 1000 rows. So if you combine both, it will become 14 columns and 1000 rows, which is showing over here. If you see, it's showing over here. Now, this axis means it will combine your data horizontally, and axis 0 means it will combine data vertically. So this is axis 1, this is 1, and axis 0 means vertical. So if you are confused over here, I'll write over here. So this is your horizontal, this is your vertical. So over here it is axis equal to 0, and over here it is axis equal to 1. Perfect. So if you have mentioned axis 1, it will combine your data as per this rule horizontally. But if you write axis equal to 0, it will combine your data vertically. But by default, this concat operation has an axis 0. But if you don't write anything, by default it will take axis 0. I hope it's clear now. So what I'll do now, I'll change this to axis 0. So as soon as I change into 0, you will have a 7 column and 2000 row. It means that data has vertically combined. And now I'll write over here patient. I'll save that into one variable that is called patient data. Patient data. Perfect. We have this data now. If you check the shape of this data, dot shape, you have 2000 columns and 2000 row and 7 columns. Why? Because it has combined the data vertically, guys. If you mention 1 over here, it will be horizontal. And by default, if you don't write anything, concat combine the data vertically. Makes sense, right? Now we have one more data, that is policy data. So we will use this also. So let's take this, and I'll copy the path from here, copy the path, and over here write policy file path equal to this we have. So I'll use this inverted comma. Perfect. Now over here, policy data equal to pd.excel, pd.read excel, because this policy file have only one sheet. But if you want to see that, let's try to see that. So pd.excel file, and over here you just write policy file path. Okay, execute this. Now take this policy data dot sheet names. We have only one, so it is not worth to use this Excel file. We will use directly pd.read excel, because we have only one sheet, guys. So we can directly use over here pd.read excel. Okay, pd.read excel. Now execute this and remove this part. Dot save. Let's see how many data we have. We have a 2000 data and 4 rows. Now let's try to policy data over here. So policy data have policy number, provider name, and coverage amount, and start year. So these 4 columns we have. Next, what we want, that if you see our this patient data, in this patient data, let's try to get this over here. Patient data dot head, I'll take. So this also have a policy number, and this policy also have a policy number. And what I want, that I want to combine this whole data and make it one, so that in one data I should have a patient ID, patient name, age, email, policy type, year, then provider name, coverage amount, and start year. So all I can have into one. So for that, how we can combine this? Can we use the concatenation? Let's try that. So I'll write over here pd.concat, and over here I need to use one list. Under the list, I will pass over here this patient data, comma, and then this policy data. How I want to join this? I want to join horizontally. So I'll write over here axis equal to 1. We have a problem now. Re-indexing only valid with unique value index object. There is an invalid index error I am getting. First question. Why I want to use axis 1? Because I have a patient data. Patient data, which is over here, let's say. Now I have a policy data. Both the data are related to each other. Means we have a policy ID, and related to the policy information, we have all the information under the policy data. Related to the patient, we have over here. So both the data are not exactly same. So you cannot bring this data over here. You have to combine this data. You have to combine this data in horizontal way. That's why I'm using the axis equal to 1. I think I'm making sense. Now coming to the error. What kind of error we are getting? So let's see that what kind of error it is. Re-indexing only valid with unique value index object. So they are saying that it cannot be add both the data because of the invalid index. Because concatenation take place based upon the index, guys. Although we have a policy number column in both the data, we have not passed anything. So by default, this concatenation will perform based upon the index of this policy data and patient data. So if you see the patient data, just remove this head from here. And if you try to do this, you have a mixed of index. So that is not possible. So we have to rearrange that. So what I'll do, dot reset index. I'll use reset index over here. Now, as soon as I have done reset index, the index starting from the 0 to 1999, but we have also one column over here, index, that we can drop later on. But let's see that whether we have this index from 0 to 1099 available, or we have to use something else. Yes, it is not. It has not changed for the schema level. It has changed for the instance level. So what I'll do, I'll just use this, or you can just pass over here in place equal to true. In place equal to true, and then now let's try to execute this. So you have this index 0 to 1099, and also policy data have a 0 to 1099, but we have one unnecessary column, that is this one. So we'll remove that part. So first let's make this head, okay, and then use one more column over here, one more cell to remove this part. I want to drop the column which is index. So how we can drop? I'll write over here, drop the column index. How we can drop this? So we'll write over here patient data dot drop and columns equal to index. Done, right? And I'll write over here in place, because I want to change that on the schema level. In place equal to true. Done, guys. It's done. Now if you want to check again, patient data dot head. Now if you are confused why I'm doing all this activity, so I try to use the concat and I'm getting the error over here that re-indexing only valid with unique valued index object. It means that we are getting a problem with the index level. And when we check over here, our policy data have a index 79, 117. It's not arranged from 0 to 2000 or 0 to 1199. So for that only, what I have done, we have re-indexed that, reset the index. As soon as I have reset the index, we have an index from 0 to 1099, but this index become the column. So that's why I am dropping that column. Index column we don't need. There's unnecessarily it's created because of this reset of index. So I have dropped that part. Now, if you see, we have all 7 columns, 1, 2, 3, 4, 5, 6, 7. And an index also from 0 to 1999. Now, let's try to execute this one. Again, I've executed this and we have now 11 column and 2000 rows. So patient ID, patient name, patient age, email, policy, policy type, year, and next we also have over here provider name, coverage, and start year. Perfect. But so if you see this data from this patient ID till this year, this is from your patient data, and from this policy number to the start year is your policy data. Perfect. And this data has basically aligned, or you can say that joined or concatenated based upon the index. So index 0 of your patient data and index 0 of your policy data combined, and on this level you have this over here. Perfect. So now see that. Let's see. Patient ID 80 is at index 0. So let's go to the patient. First, patient ID is 80 at index 0. Patient name is Krishna Kumar. Age is 80 again. And you have the policy number is this one, 8226. And policy type is premium over here. Perfect. 8226. Please remember this. Or let's copy this from here. This one. Perfect, guys. Let's copy over here and keep over here. Now let's come back to the policy data. On index 0 we have a policy number, this policy provider, coverage amount, and start year. Take this also and paste it. So if you'll see that this policy number and this policy number are not same, but why it has combined? It has combined based upon the index. Both the data index is 0, so based upon that it has combined, but policy number is not same. Because of that, the information corresponding to this customer, whatever we have the policy, I would say information, that is wrong. So whenever you have some relational data means in the policy data, your policy number column is same as a policy number column into the patient data. So it's a relational based data, I would say that. In like a SQL, one is the primary key, another is a foreign key. So in that case, you cannot use the concatenation, guys. You cannot use concatenation on relational database data, or not database data, because concat perform based on index match, and both the index has no not the same policy number, so it's a wrong, I would say, concatenation. I hope it's making sense. So I'll just cover this part. I'll comment out this. This is not the actual code. So how we can do this? We have to perform the merge query over here. Merge is similar to the join into the SQL. So how we'll do this? Let's try to see this. So what I'll do over here, I'll write, let's say pd dot or patient data. I'll take directly the patient data, which is over here. Patient data dot merge. Okay, and then I'll pass over here. I will pass over here policy data. Then how you want to perform this? I want to perform this on the left join. You know, if you know the SQL, you know left join, right? So I want to perform on the left join on what columns? So I want to join is based upon the policy number columns. So I'll write over here. See, it is similar to your SQL left join. You have to specify over here left and the based upon common columns, that is a policy number. So based upon that, it will perform the merge. And as soon as you perform this, you have patient ID, patient name, patient age, email, policy number, policy type, year, provider name and coverage, then start year. So all those columns you have. And over here, you will not see the policy number twice. Why? Because we already have a policy number. Why you have not seen that twice? Because it has joined on the policy number. But if you want to specify, you have one more method to do this. How? If both the condition 2 over here. I think, guys, I'm not confusing you, right? So if you're confused, let's try to understand. So this is how you can perform the merge based upon the common column. Perfect, right? But now, case number 2 in the merge, case number 2, if both the data frame common columns name is not same, what you will do in this case? What you will do in this case? What I'm trying to show over here is we have a common column, that is a policy number. If that policy number column name is not same in policy data and patient data, then what you will do in that case? So let's try to understand that also. What I'll do over here, I'll take this policy data first. Policy data dot rename, and over here write column equal to, I'll pass this policy number. Now your question will be, why I'm doing this? Because now I want to create that conflict over here, that both the data frame has not a common column name. The common column name is not same. So how we'll perform the merge? So in current situation, both the data frame has a common column name. Common column has the same name, column name. I want to change that intentionally. Then I want to see how that merge will work. So what I'll do over here, I'll make this, let's say, policy number. So you have now, if you see policy number in the policy data, now make this in place equal to true. In place equal to true. Done. Now if you check your policy data dot head, the column name has been changed. The column name has been changed to this small policy, small p with policy and number. Now I want to do the merge. So let's take this part and let's write it over here. So I want to merge my policy data with the patient data, which I have already done over here, but I have not saved into any variable. So this is only for this cell. Again, similar way, I want to perform over here in this current scenario. My this policy number column name has changed in the policy data. So now try to execute this. What I'm doing, again, patient data dot merge means join with patient data what? Policy data. How? Left join means left will be on the left side, there will be a patient data, on the right side there will be a policy data, as it has done over here. See, from patient name to year is the patient data, which is on the left. On the right, which is the policy data. So why? Because I have used the left over here. So similar way, I want to join this. So now let's execute this. Will it work or not? It will not. Why? Because if you see over here, policy number means this column is not exactly same into your policy data. It is a policy number. So can we join now or not? Of course we can join that, but you have to specify over here, that is left on means on the left table what is the column with you want to join, and on the right which is the column name, or in the right table or right data frame which is the column name on which basis you want to join your data, both the data frame. So on left the column name is policy number with the capital P and capital N, and right on the right side we have policy data. In that policy data table I want to join based upon the policy number data columns where P is small and N is small. So now let's try to execute this, and you have a complete table over here after joining. So if you'll see policy number and here also policy number. Perfect. Now if you try to match, it is both the policy are matching. So it has joined the data very much on the policy number, and wherever it is matching, based upon that only it has joined, guys. And it is a left join, means all the data from your patient data and only the matching data from the right table. I think you know this already, right? Because as you know SQL, so I think you will be aware of what is the left join. So left join means all the data from your left table. Let's say this is one table and this is the another table, and I'm performing the left join on policy number. So all the data from your patient table, and only the common data from your policy table. Why? Because on the left I have used the patient table, patient data, and on the right I have used the policy data. So this is how it is going to join. And if you see that this policy and this policy number is same, it means that the information of provider, coverage and year all are associated to this policy number only. It's not a mismatch now. So with this you have understood in which scenario you can use the concatenation and in which scenario you can use the merge. Perfect, guys. So now what I'll do that I'll save this data into one of the variable. Let's take this variable name is patient data only. Patient data. Now let's take this patient data and try to see what are the things we have. So we have patient ID, patient name, age, email, policy number, policy type, year, policy number again, and provider. Next we have a coverage year, coverage amount and start year. Perfect. What I'll do, I'll remove one of the policy number because both are not required. So over here I'll write patient data dot drop columns equal to, over here I'll pass policy number. Perfect. And this has been deleted. Now what I'll do over here, I'll write in place equal to true. Now let's take this dot date. So this data have all the 11 columns, 10 columns, not 11. Perfect. If you check this save, patient data dot save, you have all this 2002 data and 10 columns. Perfect, guys. So now what I want is that I want to filter out patient data where policy type is let's say basic. Policy type is basic. So filter out the patient data where policy type is basic. So what I'll do for this, I'll take this patient data, let's say, and then I want over here policy type equal to basic, BASIC. Perfect. So if you'll see over here, we have some Boolean expression over here, false, true, false, all those. But how we can get all the data for? So what I'll do that, I will use this square bracket and call this data frame over here. So like this, you will get only those data wherever the policy type is basic. Perfect. Now I want to see that how many customer or how many patient above 40 has taken policy from let's say ICICI Lombard. Okay, I want to see that how many of the patient age 40, above 40 has taken the policy from ICICI Lombard. So for that, what I'll do, again, I need this policy data. Use this policy data over here. Then first is age should be greater than 40. So I'll use over here patient age greater than 40. Now use the, I try to filter this first. So what I'll do, I'll just use over here this patient data frame. So these are the patient whose age is above 40. But now next filter I want to apply that they have taken the insurance from the ICICI Lombard. So now we have to use the end operation over here. So first you keep these into the parenthesis, then use the end operation and, sorry, it's dollar, not end, and your patient data policy name, provider name equal to, it should not be here, it should be here, equal to ICICI Lombard. So take this directly. Perfect. And this should be also under the parenthesis. This condition should be under the parenthesis. So whenever you have an end operation on or operation, or let's say multiple end operation or multiple or operation, all the logic you must write under the parenthesis. So this is one logic and I have written into the parenthesis. Then I have used the end operation over here. Then again I have written over here parenthesis with, sorry, I have written over here logic 2 with the parenthesis. Perfect. And this square bracket is for this data frame to get all the data which meet this criteria. Now let's run this. So you have this data. We have a 270 rows, but I said get the how many means I want the number. Then you can use over here dot count. So it will show you that it has a 270 patient ID. So basically 270 patient has used this ICICI Lombard for the ages greater than 40, guys. Perfect. So this is one of the example. Next what I want to see, how many patient age above 50 has taken the insurance from ICICI Lombard or SDFC Ergo. So what I'll do for this, I'll write over here how many patient above age 50 are taken insurance from ICICI or HDFC. So for this, what you will do? First, I'll copy this. Control C. Patient data age should be greater than 50 and patient provider name ICICI Lombard or guys, patient data provider name, this provider name should be HDFC Ergo. So let's copy from here HDFC Ergo. It should be over here. So under this provider name, we have a two name. One is the ICICI, other is the SDFC. So I said or over here. So it should be or operation, not an AND operation. But this is also one logic for or, and this is also another logic for or. So there will be individual parentheses. I'll use parenthesis over here and parenthesis over here. Perfect. Now let's try to execute this. Or if you want, I can break this like this. Okay. Dot count. We have an error. Data object has no attribute count. Okay, it should not be this. So 379 patient has taken the insurance either from the ICICI Lombard or SDFC Ergo above age 50. Perfect, guys. If you want to see the data, just remove this count and you will be able to see the data over there. But if as soon as you use the count, you will get the number actually. So next we have a coverage amount as well, right? We have a coverage amount. So I want to see that how many of a customer invest the money between 20,000 to 40,000 for the year on 2023 to 24. So that value I want. So let me write down over here the question. How many patient has invested amount between 20,000 to 40,000 during year 2023 and 2024. So how will you find this number? So again, patient data over here, I want this coverage amount. So I'll consider this coverage amount dot between 20,000 to 40,000, right? This is what first I want to find out. So let's try to find out first this. Step by step we will complete this query. But first let's try to find how many of the customer or patient has invested the money in the insurance between the 20,000 to 40,000. There is no customer over here. How it is possible? Let's see over here. It is. So what I'll do over here is I will check the unique values available under this coverage amount. What are the unique values? We have dot unique. So all are more than, I think, lakhs. If I make this, let's say 2 lakhs to 4 lakhs, then we have a customer, guys. So sorry, the amount is not in thousand, that's in lakhs. So that's why we are not getting. So there are a customer who has, I'll make this lakhs and this also lakhs. So then, so now the new question is how many patient has invested the amount between 2 lakhs to 4 lakhs during the year 2023 and 2024 in the insurance. Okay, in insurance. So first filter I have applied for coverage amount between 2 lakhs to 4 lakhs. So we have the some patient ID over here. The total patient is 477 for this range 2 lakhs to 4 lakhs. Next is the year should be 2023-2024. So starting year should be 2023-2024. So what I'll do over here, I'll write the end operation and your patient data. Next, I want to pass over here that your starting year dot is in 2023 to 2024. And I have a two logic, so it should be under the parenthesis, guys. Hope I am making sense that. See, the pandas is similar to your SQL actually. There is a problem. Series didn't take 2 positional argument, but 3 has given. Okay, let's pass this into the list. This one. Now we have a 248, I would say, customer who has taken the insurance between 2 to 4 lakhs in the starting year of 2023 and 2024. If you want, I can just filter out patient ID and I'll count that patient ID, because patient ID always will be unique. For one patient, there is only one patient ID. So that's why we have no chance of having a duplicate patient ID. In that case, I will try to check the value or count of the patient ID who has taken the insurance between 2 to 4 lakhs in the year of 2023 and 2024. and we have a 248 for this. Now, I was discussing about the duplicates, but the question is how to find there is a duplicate in the data or not. That is also important. How to find there is a duplicate in the data or not. So for that, so what I'll do for this, I'll take this patient data directly over here, then dot a duplicated, and it will return you the Boolean expression, whether true or false. But as soon as you write dot sum over here, it will show you that there is a duplicate or not. So it is showing on the patient data like there is a 0 duplicates, but I want to see on the column wise. So what I'll do for that, I want to see first on my column patient ID. So I'll write over here patient ID, which is this one, dot duplicated dot sum. So as soon as I've written this, I found there is a 2 duplicates in this, but I was considering there is no duplicate patient ID. There is only patient ID will be unique, but I found there is a 2 points where we have a duplicates. Now how to find which patient ID is twice in this data frame? So what I'll do, I'll write that value counts. So see, patient ID 1173 and 1581 is twice. So there are 2 patient ID which is available twice. So let's see what are the corresponding data we have to this patient ID. So what I'll do over here, I'll write patient data plus patient data patient ID dot is in, and I'll pass these 2 ID. One ID over here, comma, another ID is this one. Why I'm passing without inverted comma? Because I'm considering that these patient ID is a data type is integer. Okay, I should pass this into the list, guys. Now take this and use over here patient ID. Try to get this. See, these 2 are twice because the name is also same, ID is also same, name is also same, and I think it's duplicated data, and both are available in 2026. So as it is available twice, I want to drop one of the records. So how we can do that? That is very easy. So I'll take this patient data over here, patient data dot drop duplicates. Okay, duplicates, and then over here we have to write subset equal to I want to delete based upon the patient ID. So I'll pass this patient ID over here. So based upon that, I want to delete, then comma, and I want to keep the first record, basically the first record. So between these 2, Krishna Mehta, patient ID 1171, I want to keep the first one. And between these 2, like patient ID 1581, I want to keep the this first one. So I'll write over here first. This is how you can remove the duplicates. So now we have a 2000 records, guys. I think at the beginning also it was 2002. So because of that. Okay. And I think you have to write over here in place equal to true also. In place equal to true. Perfect. So now if you check your patient data and over here this patient ID, this patient ID dot duplicated dot sum, you will find 0, means there is no patient ID duplicate available in this data. So before that, before this all exercise, we have done one kind of a analysis over here. How many patient has invested amount between 2 lakhs to 4 lakhs during year 2013 2024, 2023 to 2024 in insurance. So we got 248, but we are not sure those duplicate data was available in this or not. So if it is available, it means that this is a wrong analysis. So I want to rerun this again at the bottom. So what I'll do, I'll just copy this part from here to the very last cell, and I will try to execute this. And now we have 248. So those duplicate patient ID is not available in this. So next, let's try to get the data first. Dot head. Okay. I want to write the query, similar query, but different way. So how we can do that? See, over here, if you see that we have used the between and operation and many things, but what is the other way of writing this query? So what I'll do over here, I'll write patient data dot query, and then you pass your query like a SQL over. First, I want this coverage amount. So I'll write over here this coverage amount dot between 2,000 2 lakhs to 4 lakhs. Okay. And this start year. The start year dot is in 2023, 2024. It should be under the list actually. So you have this 248. What I have done, so whatever the expression you see over here, I have written inside the query like a string. So this query take all the argument as a string and it perform like a SQL query over the pandas data frame. Now let's see the other example using the query. So I want to find out, filter out patient detail whose age is greater than 40 and taken premium policy. So I want to find out this detail. So what I'll do for this, I'll just go to this patient data. I'll take this patient data directly from here, then dot query, and I'll write over here, let's say, what is the name of the column which I have? It's a patient age. So I'll copy this. Patient age should be greater than 40, but I should not write this under the inverted comma. I will use over here that directly the double inverted comma. Okay, 40, and it should be and over here. Next is a premium policy. So that should be the policy type. I'll take this policy type over here and I'll write policy type equal to I have to use over here premium, this premium under the single inverted comma because this is a string, and then double inverted comma to complete the query. Now try to execute this. We have an error. What is the error? This and. Okay, this should be small and actually. And now we have a data. There are 321 patients who has taken the premium policy and whose age is more than 40. So this is how you can use the query as well in the pandas data frame to filter out or do the analysis, I would say. Next, I want to find out how many patient email ID contains gmail.com. that I want to find out. So what I'll do, I'll just take this patient data dot, sorry, not dot, I'll just pass over here email dot str dot contains, and you pass over here at gmail.com, and now use this patient data to get all the data over here. So 632. If you want, you just pass over here patient ID, patient ID dot count. So there are 632 patients are there whose email contains gmail.com. Next, I want to find out how many patients email start with AR. AR. So what I'll do, I'll just copy the same query over here, and instead of contents, I'll write start with. Starts with, and over here it should be AR. 190. If you remove this part, let's copy this from here to here and remove this part from here. So you will get all the data first. See, Arjun Reddy, Arjun Singh, Arjun Sharma, Arjun Yadav, Arjun Joshi. And over here, if you try to find out, you have 190 emails or 190 patient detail where email start with AR. And you can use this start with to find out that. Next is that how many patient surname, or you can say the last name end with Singh. That is what I want to find out. How many patient last name end with the Singh? So I'll use the same one over here, and I'll copy this exactly same over here, and I'll remove this part from this, and over here I'll write ends with, and it should be over here Singh, S-I-N-G-H. Okay, and here it should be actually patient name. Now let's try to execute this. You have a 227 patient where last name is Singh, and all the details are over here, guys. But if you need only the count, you just copy this from here, Control C, and paste it over here. Perfect. 227. Perfect. First, I want to inform you that I am using the same AbbVie file that I have used in the previous video and starting of Pandas video. So if you have not watched those videos, I request you please first go through those videos, because that is more important to build the basics and more, I would say more than basics. So yeah, so these are the topic which we are understand in today's video, and this will take time because there are a lot of topics I have listed down. But have a patience and enjoy the video, guys. Perfect. So I have the this data frame, that is patient data, where I have patient ID, patient name, and coverage amount and starting year. So I think in last video you have observed that I have concatenated 2025 and 2026 data. Along with that, I have merged the policy data where I have the policy name, coverage amount, and starting year, right? So if you are not having this data, I request you first download the data from the description and go through the previous video, so you can prepare the data like this. You will have a 10 columns and 2000 rows, and after that we will apply these are the methods, and we'll understand in which scenario we should use these are the methods of Pandas. Perfect. So very first one, we're going to understand this where method. So let's see where we can apply the where method. So I have this data, right? In this data, I have this patient age, and I want to create one age category where I want the age. First, let's see what are the unique age we have here. Okay, so first what we'll see, what are the unique age we have over here. So what I'll do over here, I'll just write patient data over here, and then I'll use this patient age. Perfect. And then unique. So we have a data from 18, or you can say that we have an age from 18 to 80 year. Okay. Now we'll understand in which condition we should use the where method. So what is the application of this where method. So if you see over here, it is listed down. It is used to replace the value where a condition is false. Keep the value if condition is true, otherwise replace it. The syntax of this where is condition and other. Perfect. So let me first convert this into the markdown so that it will be as a text. Now let's use this where method and try to create one new column that will be the patient age category. So what I'll do over here, I'll use this patient data. Okay, this patient data, and I'll pass over here this patient age to this. Perfect. And I want to create one new column, so I will create over here this patient data. I'll take and I will paste over here. Then I'll give the new name to this column, and name of the column will be patient age category, let's say. I'll copy this only, so why to write and waste the time. So patient age category. And what category we want to pass, we will apply over here patient data age dot wherever we have this patient data age greater than 30 or equal to 30, let's say keep 30 only, greater than 30, I'll want to pass over here young. So you will be quite confused over here that I said if the age is greater than 30, I want to keep young. How does it make sense? So what I want to show you that first try to understand this definition. It is used to replace the value where the condition is false. When the condition is false, then it will replace that value. So wherever it will be age greater than 30, it will keep as it is, and wherever the age is not greater than 30, for that it will convert into young for this column, that is patient age category. And you will say, what about others? Like, oh, I understand, let's say we have a age from 18 to 80, and whatever the age is less 30, so let's say for 29 to 18 you want to for 18 to 29 you want to categorize this as a young. So what about 30 to 80? First let's understand for one I would say category, then we'll again do for the others. Now let's execute this, and it has been executed. Now let's take this patient data from here and write dot head to just have some 5 records, and see over here in this 5 records you are not having anything because we have I think arranged this data such a way that we have a highest age at the top. So I'll sort this data first. Dot sort values by, and I'll write over here it should be patient age. Okay, and comma ascending equal to true. Ascending equal to true I want to keep. Let's try to execute this. Now if you see that for all this 18 we have a young over here. Perfect. Or if you want, we can pass over here some of the important age, and let's see those data corresponding to that we have this patient age category or not. So I'll write over here patient data and dot is in, and I'll pass over here, let's say 18. I think it's a integer, so I'll pass like integer only. 18, let's say 25 and 29 and 31, 30 and 45. Let's try to execute this. If you see over here, it's giving the Boolean expression, right? So I think we need to pass this as a list to the patient data, right? I'll copy this from here and I'll paste it this. Now if you see, it's giving none. Why it is giving none over here? Let's see that if it is what mistake I have done over here. So I'll paste it over here is in, and let's see on the top. what we have is in, yeah, it's right, only is in, and we have this. Let's copy this from here and come back to the bottom, and let's write down and compare what mistake we have done. Okay, patient data, I should pass over here age, because until unless you don't pass the age, how it is going to perform the easing operation, right? So I'll take this patient age from here and I will pass this over here. And now let's remove this and try to execute this. Perfect. So if you see for this patient is 45, it is as it is. For 1825, it is young. So this where method is able to, I would say, pass young as a category for all the age whichever is less than 30. Right now, let's see what we want to execute is, I want to map all the age whatever we have with the certain group, and those group will be this. So I want to map like this: 0 to 29 as a young, 30 to 49 is a middle age, 50 to 60 will be early older, and above 60 will be the older age. To map all this category to the age, we will use the same where method. So I'll copy this where method from here, which I have used over here. So I'll copy this and I will paste first over here. Perfect. Then one method we have already applied. I would say one condition we have already applied, that is for this one, 0 to 29 is young. We have to go for this again. After that, this one, earlier older, and then older age. So how we can do that? Again, we'll apply the where clause over here, where, and you write over here patient data, patient age, copy this and write over here, patient data of patient age should be greater than 50, and same time that patient data, you will be quite confused how I'm calculating all this. Let me write down and then I'll explain you. Less than 30, and keep this into individual I would say parentheses. All the logic keep into the individual parentheses over here. It should be less than, I guess, less than. Okay, and then keep into the parentheses, comma, and write over here this middle age. Paste it over here. Perfect. Now execute this. Now to see the data whether it has categorized correctly or not, I'll use the same code which I have used over here to check the data. First, let me write this and let's see. For the 45, it is middle age. For the 18, it is a young age. Perfect. Now let's try to understand the code over here. Let's understand for this 45. So I'll write over here 45 is greater than 50, or 45 less than 30. So this logic will return what? False, right? It will return the false because 45 is not greater than 50. Even 45 is not less than 30. In this case, 45 is not less than 30. 45 is greater than 30. So this is also giving you the false. So whenever this is false, the overall OR logic is false. So for that, if it is false, it will change for the 45 middle age, right? You remember this where method. Where method change the value whenever it is false. So I want to make the 45, like from 30 to 49 false in the where method. I have to write such a way that from 30 to 49 come under the false, so that we can write over here middle age. Same apply for if you scroll down little over here, we have a 31. Now let's see for the 31. So over here we have a 31 is greater than 50 or 31 is less than 30. Both are giving the false, right? Both are giving the false. And if both are false, it will be replaced with the middle age. I hope you got the idea, right? Same now we'll see for the 50 to 60, that is early older. We have to write such a way that this 50 to 60 create a false statement under the where, so that we can replace with the earlier older. Okay, so dot where, and over here you just write this first patient data. Okay, patient data or patient age. Let's say that you have a 50 is greater than 60. 50 is greater than 60, no. Or let's say 50 is less than 50, no. 50 is not less than 50. You have to write over here less than 50. I'm checking this one condition over here, 50. So 50 is not greater than 60 and 50 is not less than 50 also. So in that condition it will give the false, and then only we can write over here early older. Okay, early older over here. And I think this is all about this. Okay, I miss one bracket over here. Perfect. Perfect, guys. So let's execute this now, and we have to write for the last one, that is a older age, that should be greater than 60. So what condition you will write for the last, very last one, so that your all the data whichever is above 60, that should be older age. So what I'll write over here, dot where, and over here I'll write down this, if the patient age of that is less than 60, then you have to write over here older age. Perfect. Now let's try to execute this. Done and done. Now let's take over here some of more data. Let's say one of the data from each and every category. So from the 0 to 29 I'll take 25, and from 30 to 49 I'll take the 45, and from 50 to 60 I'll take the 59, and for the above 60 I'll take the 80. So from each category I have taken one age, and let's see that it has mapped correctly or not. Yeah, for the 80 it is older age. For 59 it is early older. So 59 it is early older, that's right. Let's remove these two and see for these two. For 45 middle age, and what about the 25? So let's remove this and write over here 25, 26, anyone is fine, and you have a young age. Now if you want, let's get this patient data over here, and just get the unique values from this patient age category. So I'll just paste over here this, and you write dot unique, and you have a older age, early older, middle and young, all 1 2 3 4 category, which I have mentioned over here, 1 2 3 4. So this is how you can use the where clause for this. But I would say this is a bit complex. Whenever you have such category to map your data, generally we don't use the where clause. Why? Because where method is a bit complex, right? Whenever I was writing this, I had to calculate a lot for this. So it is just for a simple data. Whenever, let's say you have one data over here, let's say this one, new India insurance, and I want to change this to India insurance, you can directly use the where clause for this. How? So I'll write over here this patient data, and take this provider name. Okay, just paste over here provider name and dot where uh, wherever you have a this patient data provider name equal to new India insurance, new India insurance. In that case you will change to new India, sorry, India insurance, India insurance. So let's take and see whatever we have written, it is correct or not. Let's go very first one is a ICICI Lombard. It will check, it will give the false, and for that it will change this. So you cannot write this. You know that where method will replace with a new value whenever it is a false. And for all this, apart from new India assurance, for all the other provider it will be false. So you cannot write like this. You have to write not equal to. So provider name not equal to new India assurance. So if you go for ICICI Lombard, it is not equal to. So it is true, it will not change. Come to Star Health, same, it is not a new India assurance, so it will be false, so it will not change. Come to new India assurance, both are equal to, but it's showing not equal to, but both are equal to, so it will be false and it will change that. So now let's execute this. See over here, there is no new India assurance over here. Okay, so let's copy this and change in the data itself. So I'll write equal to and pass the column name, guys. Okay, done. Now let's take this patient data and use over here. Now if you see over here, I don't see any name of this new insurance. So let's take the unique values of this providers. Dot unique. I'll write over here dot unique. And if you see over here, India S insurance, right? So this is how you can use the where. Now let's say if there is any negative age, you can make that 0. So in that case you can use the where method. Let's say some of the I would say numbers, or let's say years, are in 0, or let's say negative, you can make it 0. So in that case you can use the where method. Perfect. Now what is the next to see? Let me change this into documents, otherwise it will create a problem. Okay, now what is the next method that we have to check? Or what I'll do, that I'll copy this all and I'll keep somewhere in the new file, so it will be easy always to refer this. So Control C, and I'll take one txt file, let's say pandas.txt. Perfect, and just paste over here, so we can refer always from there. Okay, so next is mask. We will see this mask method, mask main. It's not a mask main, it is a mask method. Okay, so guys, this mask is exactly similar and opposite to where. What this mask say that? Mask say that it will change the value whenever it is condition is true. Mask say that it will change the value whenever the condition is true. It is exactly opposite of your where. Now let's see this method. So I'll use the same example which I have used over here to make available for mask. So I will create one more new column to categorize the age using the mask. Let's create a new cell over here and then copy this patient data and write over here mask age example. Okay, equal to patient data, this patient data, and then you need the patient age. dot mask and then apply your patient data of patient age whenever it is a less than 30. You make this young, right? Young. Perfect. Now dot mask and write over here this patient age. Copy this and write over here if your patient age is between your 30 to 50. So whenever your patient age is greater than or equal to 30 and same time and same time, if your patient age is less than what? Less than 60. So I'll write over here less than 50, actually not 60, less than 50. In that case, you will write over here middle age. Okay, just write over here middle age and close this. Perfect. Now next is the 50 to 60. So I'll write dot mask and over here your patient age. This I'll copy it all actually, both the logic. Okay, and I'll paste it over here. And then I want to use for this one, middle age is done. So early age, early older. So early older is including the 50 and 60. So whenever your patient age is greater than equal to 50 and less than equal to 60, less than equal to 60, in that case you will mark as a early older. Okay, so paste over here early older. Otherwise dot mask. Otherwise, whenever your patient age is greater than 60, so I'll write over here, I'll remove greater than this 60. It's not a 50, it is a 60. In that case, you will write over here older age. So this is very straightforward, guys, right? It will be very straightforward. Now let's execute this. Okay, so now let's understand how this is working. See, mask is straightforward. Whenever condition is true, it will change the value. So if the condition, let's say I mentioned over here condition, age is less than 30. Whenever the age is less than 30, mark as a young. Straightforward, right? Now over here I have mentioned if the age is greater than equal to 30 and less than 50, so age is from 30 to 49. In that case, middle age. Next, I have marked over here if the age of the patient is greater than equal to 50 and less than equal to 60, early older. And for the last one, it is greater than 60, older. Perfect. So now let's take this patient data and see that. If you see over here, older, middle, so it is exactly same way mapped, right? 57, it's an early older. If you see over here 80, it is a older age. So this is how you can use the mask as well. Again, this mask is not a right, I would say, method to give the category to your age. Why? Because you have a lot of things to write over here, but I would say it is quite easy than where. Okay, but you know, if you want to use the mask, it will be opposite of where, right? But I would give you one code, or let's say one trick, that whenever you have a such a big category to map, you can directly use, I think, 1 or 2 line of code and it will work. So how it should be? So what I'll do for that, I will use PD cut for that. Let me write down over here. See, I have given the bins 0, 30, 50, 60, 100. And 0 to 30 I have given young, then middle age, early older, and senior. Basically, older age I have converted into senior, but you can give anything over here. I have created the bins and I created the labels for that. And then I have created over here, instead of df, I have to use the patient data. So I'll copy this patient data over here, and then it should be patient age. So I'll copy this patient age also over here, and exactly same I think it should be over here also. So PD cut is one of the method which is used for creating the bins, or you can say category. So I have used PD cuts. Inside that I have given the my age and then bins equal to bins, which will give you the like where you want to, which are the category you want to create, right? So that I have given, labels I have given, and right equal to true. So as soon as you click on this and try to execute this patient data, it will give you the details over here, that which will create a mask. There should be one more, I guess. Patient data, it is this one, guys. By mistake, I have changed the patient age itself, if you see, but it should not be. What I'll do, that I need to run the code on the top so that it should not override the patient age over here. Okay, so give me a second, let me execute the above code and then I'll come back over here. So I have rerun the code again, and under the patient data I have added new column, that is a age remark, and I applied this PD cut on top of that patient age to get the category, that is labels, on the selected bins over here. And if you see over there in the patient data, we have a age remark as a senior, mid age, early, older, senior, and early, older. So I would say, guys, if you see this code, it is quite easy, and I would quite easy to write and readable as well. And whenever you need to create any columns based upon the existing columns to give some category conditions, I would recommend that you use the bins and labels along with that PD cut. Perfect. So now we'll understand the next method, that is NA or is null. So let's copy this and paste over here and convert that into the markdown. So these two functions are used to identify the null values in the data frame. So now let's see that how is NA and is null are used with the data frame to identify the null. So I'll just copy this data frame from here, patient data, okay, and then dot is NA, and try to execute this. Similar way, I'll just copy this from here and I'll use over here as a is null. Okay, so both are basically same function, and you can use any of one. Doesn't mean that you have to use both to identify the null value in the data frame. You can use any one, and it will return you the Boolean expression. But as soon as you write over here dot sum, it will show you that the total number of null value in each and every column of your data frame. And if you see there are 0, it means that there is no null value in our data. And similar way, you have to use over here sum as well, and it will give exactly same result. So by operational wise, both are same. You can use any one. Now what I'll do, that I will intentionally create some null values, so that will give you some kind of a sense how it will calculate and what are the number it will give if there is a null value. So create a null value in age column, age. Okay, so I'll take this patient data from here, patient data. Okay, and then over here I'll take the patient age equal to exactly same. I'll copy from here this column, and I'll use the mask, mask, and over here on the patient I'll try to apply the mask whenever is the age is above 60. I'll replace with that with none. Okay, execute this. Then now let's copy this one and try to find that how many null value we have in the patient A. So if you see over here, we have a 646 records where we have a null values, okay, in the patient age. Now similar way, we have the another one that is not null, which is exactly opposite to our is NA or is null. So if you write over here this patient data uh, with the not null, it will show you that how many of the records we have without null in each and every column. So in the patient ID we have a 2000 records, and I think in all the columns we have a 2000 record except this patient age, where we have a 1354 records without null and 654 with null, right? So now the question is over here, how we can convert this null value with some other value. So for that we have over here fill NA and drop NA, but drop NA we have already seen in the last video, so we'll understand this fill NA. So now what I'll do, I have created some null value in the age column, right? So I will replace that with some of the values. So over here I'll take patient data dot, sorry, I'll take the age column. So the age column is this one, patient age, right? I'll take this over here and I'll write dot fill NA, and I want to write over here, let's say 84, or let's write over here 77. So what will happen in this case, all this 1354 null value, it will replace by 77. Now execute this, you see, but it has not actually changed in the schema. So what you have to do for this, you just copy this one and write down over here equal to, perfect. Now if you check the is NA in sum of is NA into the patient data, it will give you the 0. Why? Because we have replaced that with the 77. So this is how you can use the over here fill NA to replace any of the null value with any of the values. Okay, next we'll understand this apply. Apply is the one of the method in the pandas which is used to apply the external, I would say, method or function which is not inbuilt in the pandas. What does it mean? What is the meaning of this? What I'm trying to say over here. So see, apply is the inbuilt function in our pandas, okay, and it is used to apply the custom function on the row and column or individual data of the data frame or series. This is the use of this apply. Now let's see that how we can use this apply with our data frame. So what I'll do over here is, I have the email, right? Over here, if you see in the patient data, let's try to print this patient data first. Okay, so in this patient data, we have an email, and I want to extract the domain from this. How we can do that? So let's see that over here. So I'll create this patient, I'll use this patient data over here, and then I'll create new column, that is the email domain. Okay, equal to, I need this data frame, that is a patient data, and I want to extract the domain from where? Email. So I'll copy this column. How you can extract the domain? So you have to use the str function split with the @. So, and that should apply each and individual rows, right? So for that I'll write over here dot apply, and over here I'll write the lambda of x, then x dot split based on the @. Okay, and take out the very last one. So if you split based upon this @, you will have a two I would say element in the list. One will be the before this @, and one will be the after this @, and I want to take out this after the @, so I want the one over here. Now execute this, and let's see our data frame. As soon as you see over here that we have already extracted the email domain from our email, and for that we have used the apply. So apply is the one of the method which is which use to apply the external function. So these are the external function, right, which applied on this column for all the data and extracted the domain and save into this column. How it is useful, right? It is very useful, guys. Now see the next example of our apply. So what is the next example? What I'll do over here is that I'll calculate the risk factor. What is the risk factor over here? So if you see that I have given, if the age is greater than 50 and policy type is basic, then it will be high risk. Okay, if the age is greater than 50 and policy type is good, then the normal risk. And if the age of the patient is greater than 50 and the policy type is platinum, then it is a normal. There's no risk, I would say. And for that I will create one function first. So here is the function. What I have done, I have created one risk factor and I have passed the row over here as a, you can say, argument. Then row of age is greater than equal to 50 and row of policy type equal to basics. In that case, return the high risk. Similar way, it is very simple, guys. Just if and elif I have used, then row of age is greater than equal to 50 and policy type is gold, then is a normal risk. If the age is greater than equal to 50 and policy type is platinum, then is a normal. Otherwise, age is below 50. I want to mention on that. So now let's use our data frame, patient data. I'll copy this patient data over here. Okay, and then I'll create a new column that will be the risk factor. Risk factor. Risk factor equal to on which column I want to apply this function. I want to apply on the age column. So I'll copy the age column from here. Instead of writing this, I'll just take this one. Okay, Control C and use over here. Perfect. Then dot apply and just write over here risk factor directly. That's all, guys. Just execute this. Risk factor is not defined. Okay, just first define this and then execute this one. What is the issue over here? Float object is not subscribable. Why? What is the float object over here? Okay, the mistake I have done over here is, if you see over here, I have used the row, means the data frame, and I'm trying to get the column of that, right? So that is the mistake I have done. So what I'll do over here, I will remove this patient age from here. Okay, and then again it will create a problem. Why? Because in the patient data we have a patient age, not an age, so it will create a problem over here. So let's change this. Okay, now run this one and also run the last one over here. Again there's an issue, patient age, and over here you just write x equal to 1. I have defined over here the function which is showing that if your patient age of the data frame is greater than equal to 50 and the row of policy type is equal to basic, then it is a high risk. And if your data frame patient is greater than equal to 50 and data frame of policy type equal to gold, in that case you have a normal risk. And same if your patient age of data frame is greater than equal to 50 and policy type is platinum, then normal. Otherwise you just mention age is below 50. So we are only giving this condition for above and equal to 50 age. Perfect. And what I have done over here, I have used over here patient data risk factor. I have created one column and I pass the entire data frame. Why? Because this data frame, as soon as I applied, or you can say the pass to this function, it will be passed as a row. That is, will be the data frame over here if you see, and then from this row will be your data frame. I am trying to get the column name, right? So it is good that I am directly passing over here the entire data frame. Then dot apply this method, and x is equal to 1 means it will try to get the column name. That's why I mentioned over here x is 1. So you apply this risk factor on this patient data by x is 1. So first it will try to extract all the column name, and whatever the column name is used under this I would say risk factor, that will be utilized to return the value which will be added to this risk factor. Perfect. Now let's try to execute this one, and at the last you will have a one new column that will have a risk factor over here. Perfect. So this is how you can use the apply a method to apply some of the custom function over the data frame and the columns, right? Next, we have a map function. Map function is very useful whenever you want to use the one hot encoding in the machine learning. Why? It is very easy. I would say that if you want to change any categorical value into the numerical value. Okay, so what is the definition of our map function? So map functions say that it is used to transform your value on the single column. Okay, map does not work on the whole data frame, it works on only the single column, guys. So in, let's say that you are using the data where you have a gender and you want to do the level encoding. So for the male you want to pass 1 and for the female 0. So in that case you can use the map function to convert that categorical feature into the numerical feature using the level encoder, and for that we use the map function, right? So let me convert this into the docker string because it will create the error. Now what I'll do over here is I have created one map that will be the policy map over here. So what I have done over here, I have given for the basic B, platinum PLT, gold G, and premium is nothing but PRE. And same map I will apply on our data frame. So we have over here this patient data. I'll copy this patient data over here. Okay, and I'll create the new column over here, that is policy map. Policy map. Okay, and equal to, we have this patient data. I'll copy this over here, and this is from our policy type, right? So I'll write over here policy type and dot map and use this policy map. Actually this is a dictionary. Basically I'm passing this dictionary to the map function, and it will try to check based upon this policy type, and it will create the policy map in our data frame. Policy map is not defined. Okay, let me execute this and then this one. Perfect. Now let's see our data. Try to execute over here, and if you go to the last, there will be one column which will show you the policy map over here, PLT, PLT, PRE, B. So upon the your policy type, which is over here, right? Platinum is PLT and basic is B over here, and over here premium is a PRE. So this is how you can use the map function, guys. Perfect. Now what is the next one? Next one, we have a split the column. So we'll see that one. So column is split. How this column is split works? Column is split. So for that I have one very unique, I would say, example to explain this. We have our this patient name. In that we have a first name and last name. What I want to create, that I want to create two different column with the first name and last name based upon our patient name. So I'll just take this patient data over here. Okay, patient data, and I want to create two new columns. So that will be the first name, okay, comma, last name. Perfect. Based upon what you want to create, based upon my patient name I want to create. So again I'll take this patient data from here, copy this and paste it over here, and then pass your patient name to this, then dot str dot split. Split is the column which will split is the function which will split this patient name based upon the condition which I'm going to pass. So I have seen over here on the patient name we have a Krishna space Kumar, Sai space Yadav. So with all the name, the first name and last name, there is a space between that. So I will utilize the same space to split that column. Okay, and over here I'll write expand equal to true. So you have to expand it. Expand equal to true. Now execute this, and now let's see our data frame, it has been created or not. So if you see, first name and last name from the patient data has been splitted and created over here. So this is how you can use the split function to split your column. Even you can use the email also for that. Based upon this @ you can create the first name and domain from that email. Okay. Next, we have this strip upper, lower, and title also that we'll see now. So what is the use of this function? And I'll write over here one more, that is a title. See, these are, I would say, not very much used whenever you do the EDA, but it's good to know that these function also exist into the data frame. If you have seen my string operation, you will aware of that. What is the meaning of strip, lower, upper, and title? So a strip is used to remove the trailing and leading space from the given text, right? This is exactly same, I would say, which we have already covered or which we have already understood in the string operation. So a strip is used to remove leading and trailing space from the string. Okay, lower, upper, title, I think you know that, no need of definition for that. So what I'll do over here, that I'll use this patient data and I'll pass this, and I'll use the patient name over here, and I'll use dot str dot split, sorry, not a split, is a strip, a strip. So this will remove if there is any kind of a space are there, but if there is no space, it will be as it is. It is just to clean the data, guys. This kind of function I'll use. Now if I use lower, it will make the entire function in entire data into lower. It should be, I think, str dot lower. So it will make into the lower. You can use without the strip also. So what I'll do, I'll copy this over here and I'll just pass this str lower over here. Okay, so it will make your string into the lower case. And if you pass over here, instead of lower, if you pass to upper, it will make your string to the upper. Perfect. So it will make to the upper. And if you pass over here title, then it will, what it will do, you know very well, right? It will convert your title. It will convert your string, the first character in capital of each word. Perfect. So this is how your str of upper, lower, title, and strip works. Now let's see the group by, which is very much important, guys. Group by and group multiple column group by, egg function, pivot table. So we will see all these now. These are the very much important whenever you perform some of the analysis on the data. So let's see and keep this over here. Okay, from the group by name itself, it is clear that it is used to create the group of columns, right? So we use the same over here. So what I'll do, that I want to know that how many member each provider has. Like in our data, we have a provider like SDFC, Ergo, ICICI, Lombard, and India Insurance, right? So I want to know that each provider how many members has. So what I'll do for this, I'll write over here patient data. Okay, and now I'll use the group by dot group by, and I'll use over here this policy provider name. Okay, I'll pass it over here. Then over here I want the patient ID that I will count actually. Dot count, count. It should be small. Now let's see that. So you have this count where each provider having their count, like how many provider, how many member they has. Okay, so in that, if you see that the highest is I would say India Insurance, which having a 421 of the member, right? Next, I want to see that how many patient are having a more than one insurance. What I want to see that how many patient patient has an insurance more than one company, actually not more than one company insurance, okay, one company or provider. How we will find this? So for that, what I'll do, I'll use the same patient data which I'm having over here, patient data, and then I'll take this patient ID. So dot, I want to use the group by. This group by will help me to group by this provider name based upon the patient ID, and then I'll count it. Okay, now if you see that it is showing that each patient ID having a one only, not more than that. But if I use the patient name, then it may show some different result over here. So let's see over here. So over here, if you see that, see, each and every patient have a more than one providers, or it also show that maybe this name are multiple time and aligned with the multiple providers. So it's a many to many relation, guys, but that's okay. I want to find out only that. So this is how it is. Next, I want to find out that average coverage amount by each provider. How we can do that? We can use the patient data group by, and over here I'll use this provider name. Perfect. This is the column name, and over here it should be the coverage amount. So coverage amount. Okay, and I want the mean, that is average, so I'll use the mean over here. It will give the error. Why? Because coverage amount name is not exactly same, I guess. I was expecting that. So I'll just copy the column name from here and I'll paste it directly to our code. Then it will not create any kind of a error. Now let's execute this, and here you are. Now if you write over here dot reset index, it will create the data frame, and you can save that into one of the, let's say, a result column, result variable, and you can print that later on, or whenever you want, you can save that into the Excel as well. So now if I write over here dot to, and let's say CSV, and if I pass over here, let's say a result dot CSV and index equal to false, it will save this data into the CSV. Let me execute this. Executed. Now if you see over here, it will create the result.csv and it will have this detail. So this is how you can save the data also in the Excel from the data frame. Perfect. Next, I want to find out like how much coverage amount each provider is giving in each category of age, category of age. So for that, which kind of column we are going to use over here? We have to use the coverage amount, provider, and age category. So we have a 3 age category, right? So if you see over here, patient data dot head, you will see that there will be a 3 different categories. So anyone we can use that. Let's take the age remark. Okay, and I'll use the same over here. So patient data and dot group by, and pass over here both the columns. One is the age remark and the second one will be the provider, which is over here. So both, based upon both, I want to get the sum of my coverage amount. Then only it will be identifiable that each category of age, how much each agency are paying. So under the young, if you see that this HDFC Ergo is paying this much of amount, and ICICI Lombard is paying this much of amount, and so on, guys. If you want, you can make this dot reset of index, and it will convert this into the data frame. Perfect. So I think you understand what is the use of group by, and how with the one column or multiple column we can identify or we can group by the data and find some of the more detailed analysis, right? Next we'll understand and try to analyze that, like if you see over here on the top, where it is this one. So each patient have a more than one provider's insurance. So I want to find the name of the provider also. So how we can do that one? So what I want that I want to find out each provider, each provider count, name against patient name, patient name. So how we can do this one? So for that, what we'll do that we'll use the patient data. Of course, we don't have any other data over here. Then dot group by, okay, and then you pass over here patient name, which is over here, let's say patient name, okay. And then what I want to find, that I want to find the count as well as the list of the provider, so based upon the patient name. So I'll keep the patient name over here on the group by, then dot, I'll use the egg, that is the aggregation function, and inside that I want the provider count. So I'll write over here provider count equal to, I'll take this provider from here, okay, and I want the unique count, like how many actual unique provider are in each and every patient, or each and every patient how many unique providers insurance has taken. So I'll write over here n unique, perfect, and it should be under the inverted comma, then comma over here, and over here I want the provider list, right? Provider list equal to, I'll take the provider name, comma, lambda of x, and then x dot unique, and I want this into the list, so I'll pass over here list, guys. Okay, so what is happening over here? See, I'm using the patient data, I'm using the group by to group my data based upon the patient name, and I'm using the AGG, that is a aggregation function, to find out the count of unique count of the provider and the name into the list. So for the name, I'm using this lambda x, that is the annonym function. I think I already explained what is lambda, right? So this x will go to this provider and try to find the unique name basically, and we'll club that into the list. Execute this now. We have an issue which is basically patient name. So there is an error in the patient name. So I'll just copy this over here and try to get the patient name from here. Okay, and pass it. Try to execute this. So if you see that I have this, but I cannot see all the column names. So what I'll do, I'll use one of the functionality of the pandas which help us to get all the column name over here. So I'll write over here pd.set option display max column width. Okay, so this will help us to get all the detailed name of my provider in the list. Okay, so it has basically ICICI Lombard, Indian Insurance, HDFC Ergo, Max Bupa, and Star Health for this Arab Gupta. So there are 5 in this. Vivan Reddy, we have they have taken the 4 different insurance providers insurance. So this is all the name of the insurance provider. Perfect, guys. I hope this is making sense how you can use the egg function to get the detailed analysis over here. What is egg over here? Egg, AWG, is a short form of aggregator, which is help us to create a multi-level of the aggregator over here. So one is giving the count, other is a list of the providers, and for that I'm using the lambda function over here. Now let's see the one more example of my aggregator, that is the egg function. So what I'll do for that, I want to find the sum, mean, max and average of coverage amount. So what I'll do for this, I'll use the same patient data, and over here I'll use the coverage underscore amount, and I think the C should be capital. So I'll use this C as a capital, dot AGG, and under this I'll pass all the sum, then max, then mean, and then average in the list actually. So this will create the over here your coverage amount against sum, max, mean and everything. But this is not making sense over here. I just want to show you that how this egg function can help you to find the multiple aggregator along with your data. Perfect. Let's say that I want to find out exactly same average, mean, max, sum against your policy provider. So what I'll do over here, I'll use this patient data and then policy provider name, this provider name. Perfect. Sorry, it should be under the group by dot group by, and under this you pass this provider name, then dot AGG, and over here you pass all the detail whatever you want to find. So total coverage. Okay, for this you pass in the tuple coverage amount, comma, sum. Perfect, guys. Now same I want to pass for the other one. It should not be under the inverted comma, it should be because it should be outside of that. Next I want to find the average coverage, AVG coverage equal to, copy this from here and paste it over here and write over here mean, because you want to find the what, average. Then you want to find out the max, so max coverage equal to, you just copy this from here and paste it over here and write over here max. Okay, perfect. Next, let's say if you want to find the mean, so mean coverage. Okay, mean coverage equal to, write down over here this coverage amount and comma, over here just write a mean. Okay, now execute this and you have all the details over there. This is how you can use the egg function to create a different in detail aggregator against your any of the column. Perfect. So now we'll understand the pivot table and pivot, how it is useful in the data frame. So pivot and pivot table both are used to convert the data, reshape the data. And the syntax of the pivot is index, column, and value. So pivot is used to reshape the data, but it can not handle the duplicate value. Please make a note that pivot is used to reshape the data, but it cannot handle the duplicate. And pivot table is more powerful than the pivot. Why? Because it supports the aggregation function like sum, mean, max, right? So we'll understand both, and trust me that whenever you want to find out some of the in-depth aggregation based upon two different column, you can use the pivot table over the pivot. But I will show you both actually how you can use the pivot and pivot table. So over here I'll show you one of the example of the pivot. So I'll just take the patient data and dot pivot, this pivot, and over here I'll pass the index equal to, because your syntax of the pivot is index, column, and value. So index equal to, I'll pass the provider name. Okay, so I'll take this provider name, I'll pass over here. And next I want to pass column, or let's say I'll not pass the column, I'll just keep the value. Or let's say that columns equal to, I'll take some of the column from here, which will be, let's say, of year. Let's take this year. Okay, and I'll pass over here year, and then comma, values equal to, I'll pass the coverage amount. Perfect. Index content duplicate in it cannot reshape. So as mentioned on this, that a pivot cannot take the duplicate value, so that's why it is not able to reshape this. So what I'll do, I'll just remove this part from here. Let's say pivot missing one argument, that is columns. So make these columns. Okay, so this is the columns and this is the value I'm passing over here. So if you see over here, all the provider columns detail, or you can say the entity, has been converted into the column, and corresponding to that we have the values over here. But that is not more useful, it does not give any, I would say, more insightful from here. But I'm just giving one example that how you can use the pivot, right? You cannot use the index over here. Why? Because the column having a duplicate values. Okay, now let's see the one of the example of the pivot table, guys. For the pivot table, what I'll do that I want to analyze the coverage amount by provider name and policy type. So if I want to analyze this coverage amount, what kind of analysis you can perform for analyzing the coverage amount? Let's say sum or mean or max. Okay, so I'll use over here patient data dot pivot table. If you have used the Excel, this is exactly same pivot table you can use over here. Okay, but for that you have to write the code. Pivot table, then you have to pass the index equal to, I'll pass over a provider name. Index is nothing but in your Excel pivot table, whatever you pass in the row, that is over here as an index. Okay, next columns equal to, you can pass over here policy type. Okay, and then comma, values equal to coverage amount. Perfect. After that you just pass over here egg function equal to, over here, sum and comma mean. Perfect. Now let's try to execute this. As soon as you execute this, you will see that in the provider name you have all the providers name. Then over here you have a policy type, that is a basic, gold, platinum and premium, and top of that you have a sum of that. So it is showing you the sum of the coverage amount under the each provider and the policy type, and the mean of the coverage amount under the policy type and the provider name. So this is how you can find the different aggregation function based upon the your different columns. That could be your provider name, policy type or XYZ. So please always remember that always pass the column name on the value. On top of that, you can perform the this sum, mean, max, average, all those aggregation function. Okay, so whatever you pass under this aggregation function, that will apply on this value. So if you pass over here some of the values, some of the column name, which is let's say a string, and if you pass this over here in the egg function, sum or mean or let's say max or standard deviation, then it will create the error. So it's always keep in the mind that the value should be the integer or float columns. Perfect. Now let's see the next detail of my analysis of the pivot table. So what I'll do over here is I'll create the new data analysis over here, where I'll use this patient data over here. Let me just replace this. Yeah, try to execute this. So what it is showing over here, so you have the coverage amount, mean and unique patient detail corresponding to that. So what I have done in this, if you see that, if you compare both the data over here, both I'm performing the pivot table in that, in the index exactly same provider name and column policy type, but in the value I have passed to different column. One is the coverage amount and another is the patient name. Patient name is the string, guys, right? That is a string. So I have passed over here separately that patient name is nothing but I want to find the unique count top of that, and this for this coverage amount I want to perform the sum and mean, and here is the result of that. I hope it is making sense, right? Next we'll understand the stack. What is stack? Stack is, you can consider a type of function which is used to make your data frame from wider to longer. So just assume that from where it stack has came from. So let's assume that you have a books and you have arranged your books like this, okay, in the cell. So you have arranged the book like this. It is taking the, I would say, more space. Instead of that, you want to keep your book, you want to stack your book basically vertically. So on top of each one book, top of the another one, and this is called stack. So from your wider to longer, it is wider of course, and this is longer. So that is the use of the stack in the data frame also. So now let's see that how you can convert your this large data frame into the longer data frame using the stack. So what I'll do for this, I will just get the data frame, that is a patient data. Okay, patient data. Perfect. And now you just perform over here dot stack, and it will be converted into the stack from the wider to longer. You can save this also to stack data frame. The stack data equal to. Perfect. And now let's try to execute this over here. So the length of this data is more, so that's why you are able to see only 0 to 2001. So but if you want, you can pass over here, let's say 0 to 20. But in the 20 you will see only the first one. So let's make this 200. It is not showing because the space over here is less, that's why. But if you want, we can save this data into CSV. So what I'll do for this, so let's say stack data dot to, and over here let's say CSV, and I'll pass over here stack data stack dot CSV. CSV. Okay, execute this. Done. Now let's come over here, and if you see that stack over here, and here is the data, guys. See, for the index 0 from here to here. So how this stack is working? So this your complete horizontal data has converted into vertical, and each and every data points are stacked over here. So this is the 0th index starting from here and ending over here, which was before horizontally, now it is vertically, right? And for each and every data you have their columns over here. Perfect. Now if you want to make this again to data frame, so you can use this stack stack data dot unstack. So it will get back to the original data frame. But it is always important whenever you are handling with the stack. So once you converted the data into a stack, and whenever you want to again to convert back into data frame using the unstack never ever handle with the duplicate values. So what does it mean that? So now to understand that it never ever handle the duplicate value, I'll give one example over here. So what I'll do for this is I will create one new data frame over here. So let's say I'll take over here, let's say df1 equal to patient data dot set index, and over here I'll pass patient name. Okay, I'll take this patient name, and over here also I'll take the patient age, which is this one. Okay, let me copy this over here, guys. Now let me execute this. Executed. Now let's try to see the data over here. If you see the data, I have converted this patient name and patient age into the index. Now I'll perform on that stack. Okay, converted, easy. Over here you have the patient name, patient age. For that you have the patient ID2, or if you want, let's keep this also in one of the data frame, df2. Okay, perfect. Now a df2 of, let's say, 0 to 200. It is not able to show all the data, so let's make this to 20. So at least you have the very first one and second one now. Perfect. Now what I'll do that, till now it is easy. What I have done, I have taken this patient data, I have set the index and patient name and patient age, and I save this complete I would say operation into the new data frame, that is df1, and I have performed the stack on the df1 and save into the df2. So this is just one kind of a slicing. I'm trying to see the data based upon that. So df2 is my stack data. Now I want to convert that into the original data frame. So what I'll do, df2.unstack. Perfect. So as soon as you execute this, it will give the error. Why? Index content duplicate entities cannot resave. What does it mean? It means that if you try to find out, let me show you that what is the meaning of this and why it is not able to perform the unstack on this. So now I'll write over here df2 dot xs, that is the cross tab, and I'll try to find one of the patient name, that is the Aditya Yadav. Okay, and I'll paste it over here. Now let's see this. It should show all the records, but it is not showing. So what I'll do that, I'll create over here. So I'll pass over here pandas set option display maximum row as a 200. Now execute this. So still it is not able to execute and show that. Until unless I don't see this, it will be difficult to explain you that what I'm trying to show, that index content duplicate entity cannot resave. Or let's say with the data frame, let me come back and write over here patient, patient, patient data. Perfect. Patient data, and over here I want to find out this patient name. Patient name equal to I want this Aditya Yadav over here. Okay, and then just close this patient data over here. So if you see that Aditya Yadav, this data and this data, both are with the name and age is same. So what is happening over here? Let's try to understand. As soon as I have set the index as a patient name and patient age with the and save into df1, I convert it into the stack, and then I want to do the unstack. So I'm getting the error. The error is that index content duplicate entity cannot resave. What is index content duplicate entity cannot resave? What does it mean? So my index for df2 or df1 is patient id and age, sorry, patient age and the patient name, right? That is the my what index, and index is duplicate, that is Aditya Yadav and 77. That is more than one time, that is 3 times. That's why it is not able to do the unstack on that. Index cannot be the duplicate. If it is duplicate, it will not able to do the unstacking, guys. I hope it is making sense, right? We have already covered this much, unstack and stack. Now cross tab, rank, rolling window and resampling are due. So now we'll understand the cross tab. So what is cross tab? Cross tab create the frequency table between 2 or more columns. So that is nothing but the cross tab. To find out the frequency table between 2 or more columns, what I'll do that I'll write over here pd dot cross tab, okay, and then over here patient data, and pass over here, let's say provider name, comma, patient data, and over here policy type, and let's try to execute this. Patient data is not defined. I think I should copy this from here and pass this to here. Perfect. Execute this. What is the issue? Provider name, this should be capital N, I guess. What is next? Policy type. What is the issue over here? Okay, this is the name of the policy type, so I'll pass over here. That's why always I try to copy the column name. So if you see over here, it is showing that how many basic, gold, premium, platinum are available into each and every provider name. This can be achieved using the pivot table also. So what I'll do over here, I'll write this patient data, okay, and dot pivot table, and over here index equal to, I'll write the provider name, okay, and over here comma, columns equal to, I write the policy type, okay, and over here I'll use the value equal to age, patient age, and over here egg function equal to count. Now execute this and it will show you exactly same records over here. What is showing this over here? It is showing that like for this HDFC Ergo, how many basic plans are there in the data. For ICICI Lombard, how many premium plans are there in the data. So this is how it is showing, but I think this cross tab is quite easy than the pivot table to find the count of that. Here you need the 3 column. Patient is also to calculate the count, but with this provider name and policy type, using this cross tab you can easily find this, right? So this is the example of the cross tab which is used to find out the frequency between the 2 different columns. Perfect. Now next can be that under the each category of the age, how many patients are there. So for that, what you will do, you will write the pd dot cross tab, and over here patient data, just write down over here patient data, and over here it should be age frequency, right? I'll copy from here, patient age category, patient age category, and comma, I need this over here, and I want under the each category how many patients are there, right? So how many patients are there, then I should get the patient ID. Okay, but I think it will going to create the problem. What is the problem? Let's see, that is the problem it has. It is not between the these kind of columns where you have a 1-to-1 almost relation, because see, early age, I think only one time it is available for the young, but instead of that, if I write the patient name, it will make sense, right? Take this patient name, and if you pass over here, it will make sense, but it will have a long list over here, because it's trying to find the frequency of the each and every name under the each and every each category patient age. Perfect, guys. Or if you want, you can just pass over here this policy type, so it will show that under each and every your age category how many policy type are there. So if you see under the early older, what is the maximum policy type has taken? So I would say the basic one. Under the young, if you see that under the young category, the maximum policy type has taken, that is basically platinum. Perfect. In the middle age, the lowest policy type has been taken, that is basic. Clear, guys? So this is how it is showing that. Next, we'll understand the rank function. So what is the rank function? Rank function is assign the rank to the value to the data frame or series. By default, rank is in the ascending order. So let's say if you want to provide the rank of your columns based upon the mean, or let's say based upon the total sum, so in that case we use the rank. So let's see over here the next example, which I want to showcase that what is the highest rank policy type based upon the coverage amount. So for that, I'll take the patient data, okay, patient data, and then I'll pass over here group by dot group by, and over here policy type type. Perfect. And then I want to find the sum of the coverage amount. Coverage amount sum I want to find out. Perfect. Now I'll use over here dot reset of index. So it will create the data frame. I'll save this into the result equal to this. Now I'll use the same result data frame to create the column of rank. So I'll pass over here rank over here, then equal to result of this coverage amount. I'll pass it over here, and dot rank, and over here ascending equal to false I'll write. Rank is by default ascending order, so I'll make this false, or you can keep also if you want false. And I want to apply the method equal to dense. What is the meaning of dense? Means if there is a tie, it will assign the same value to each. What is the meaning of dense over here? Dense is nothing but it will try to assign the same value if the rank is tie. So right now, if you see that the platinum has the highest rank, why? Because it has the highest coverage amount. Next, I want to find out, this question has asked, and not exactly this question, similar question has asked in the Tiger Analytics interview question. So find out the top one policy type in each year. So that I need to find out. So for that, what I need, the policy type, I want the coverage amount, and I also want the year. So I'll use over here patient data, right? And under this patient data, I'll write dot group by, and under the group by, I'll pass two columns. One column will be the start year, okay, a start year, and another column will be the policy type, which is over here, okay. Just pass over here. Then I want to calculate the sum of the coverage amount under the group by of these two. So I'll pass over here dot sum, and same time I'll reset also, so I can create the data frame. Reset index. Perfect. And I'll save this data into result equal to, okay. Now let's try to check your result, guys. So here you have a start year, policy type, and coverage amount. Now I'll create the rank into this. Rank equal to how you will perform the rank based upon the coverage amount. So before that, I want to find the each year. So under this 2023, which policy type has a rank 1 based upon the coverage amount? So result dot group by, and under this you pass this start year, because I want to group the rank based upon this start year. If you have work on the window function of SQL, so under that we have a partition by. Similarly over here we have a group by, okay. Then dot rank, and over here method equal to dense, okay. And it should be partitioned by, that is group by start year. But on what basis I want to apply the rank? I want to apply the rank based upon this coverage amount, so I need to pass this also over here. So how it is? Result of rank means I want to create a rank column into the result data frame, and it should be every year, like that rank should be grouped by every year, like under this 2023, which policy type based upon the amount is on the top. So for that I want to result dot group by start year, and on the coverage amount I want to create the rank, and method should be dense over here. Click on this. Now let's try to execute this over here. As soon as you execute this over here, we have, let's say for 2023 we have a 4321, and if you go for 2024 we have a 1432. Like every year we have a rank from 1 to the highest, whatever you call that, okay. Now I want to find the policy type of each year where rank is 1. So what I'll do over here, I'll try to filter this. Rank is let's say equal to 1.0, because it is in the float. Try to execute this and also pass the result to, and pass this entire slicing operation under the list of result. And you have here under the 2023, the top policy type is gold, which have a highest coverage amount. Under 2024 you have a platinum, under the 2025 you have a basic, and under the 2026 you have again premium, guys. Platinum is nowhere. Perfect. So this is how you can use the rank to assign the rank to the data frame based upon the sum of the columns. Next, what is next pending? We have seen the this rank. Now we have a rolling window and resampling. These two are due, and this will be the last topic of our video, guys. Okay, so let me write over here these two, and first we'll understand the rolling window. So rolling window is pandas is used when you want to perform a calculation on fixed size moving window of row. So whenever you have a time series data or you want to calculate the moving average or trend analysis or smoothing the data, in that case you use the rolling window where we pass the window as a 7 or 2 or 5. So this is more useful on the moving average side. If you have some idea of moving average, that's fine. Otherwise, we'll see how to calculate the moving average using this rolling window in the pandas. So what I'll do over here, I'll use, let's say, patient data again, because we don't have any other data right now, right? So patient data dot, or let's first get the data. We have this data, right? Now what I'll do, I'll again, rolling window is the function where we perform only with the integer or float based column. Why? Because you have to perform some average, mean, max or sum. So in such case you can only perform those aggregator function on the integer or float. So that's why we need the some column from here which having the integer or float. So I'll take the coverage amount. So I'll pass the coverage amount and then dot rolling window, or just rolling, it is not rolling window, rolling, and I'll take over here, let's say 7. Let's take the 3, then dot and write the mean. Mean means I want to find the average of this. So now if you see that, or let's take this also from here to here. So for first 2 it is none. Why? Because I have taken the 3. So it will take first 3 and try to find the average of that, and it will give over here. So for the first 2 it is none. Why? Because top of that it is not a 3 value to calculate the average corresponding to that. That's why. For the fourth one it will again from the second to third. So this is how this rolling window work over here, guys. So now I want to find out that the average coverage amount per policy over the year, rolling average basically. And for that, it is important our data should be arranged into the ascending order. Okay, so that is important. So for that, and if we are using the coverage amount and start of the year, I think, yeah, so in this data we have the policy type and over the year. So it is important that we should arrange the data first in ascending order based upon the policy type and over year. So what I'll do over here, I'll use the patient data dot short values. Perfect. And then I'll pass over here this policy type and start year. Policy type start year, then comma in place equal to true. So this will arrange our data into the ascending order. Now if you see this, Control C and Control V over here, it will be arranged into the ascending order based upon the policy type and start year. Perfect. Now let's take the patient data, then rolling average AVG, let's say, equal to I'll use over here this patient data dot group by, and I should group by 2 columns, that is policy type and start year, right? So I'll pass over here policy type comma, and at the last we have to pass this start year because we want to find the rolling average based upon these 2 columns, right? Then dot then coverage amount, because if you want to find the average you need the coverage amount over here, right? Coverage amount. Perfect. Then dot transform, and over here you pass lambda of x and x dot rolling, and over here window equal to 3 and minimum period equal to 1. This is what we want to transform the data and at the last we want the mean of that. I'll use the mean over here. Let's see. uh and the rolling got unexpected keyword like mean period. Okay, it should be mean periods actually. Done. Copy this patient data over here. Perfect. And now if you go to the last, you will have the rolling average. See, but for the first two, it will be, see over here. For the very first one, 233949, it is exactly same over here. Why? Because I have mentioned the minimum period equal to 1. So it will take and copy and paste as it is over here. For the second one, if you combine these two and divide, you will get this value. Okay, perfect. So this is how you can calculate the rolling average. But you will see that I have mentioned the window equal to 3, then why it is calculating over here over second one. So for that, let's remove this part. Okay, and try to execute the code. Run this and run this. Come back to the last and see over here. For these two it is none, and for the third one it is started to calculate. So it was for the minimum equal to 1, that's why I started to calculate the average from the 1 2 actually. So as soon as you write mean periods equal to 3, sorry, mean period equal to 1, what it will do, it will for the first data it will pass as it is, and for the second it will take the both the value and try to calculate. So it will take both the value and calculate. For the third one it will take all three and it will calculate the average. So that is the meaning of your mean period equal to 1 and window equal to 3. I hope you understand that what is the use of rolling window, right? So this is how it is done. So now we'll see that what is the left. So we left with very last one, that is a resampling. This is the last topic of today. So we'll understand this resampling now. So let's take one mark down and just paste over here, resampling in pandas. So resampling mostly used with data frame data when you have a data in one frequency and you want to convert that into another time frequency. It is important that your data should have a date time columns. Whenever you don't have a date time resampling in the panda, so resampling mostly used with date time data when you have a data in one frequency and you want to convert that into the another time frequency. So resampling always used for that column. So resampling always used for the date time columns, but we don't have a date time columns over here, but we have a year. So what I'll do over here, that I'll create one new I would say data frame where we will have a all the we'll have the date of 800 period. So what I'm doing over here, I'm calling this pandas as PD and numpy as a NP. I know I have not explained the numpy, but just I explain what is happening over here. So we always import the numpy with import numpy and we give the alias as a NP. So after this video, once we complete the pandas, we start the numpy also, but just understand two line of code of a numpy over here. So I'm just importing numpy over here, giving the alias to NP. Now I'm creating the date range guys over here. So pd.date range, and if you're not understanding date range, the date function will cover in the next video. So just understand from this date range will create the date from the 1st January 24th period of 800. So for the 800 days. And frequency I've given days, means 800 it will create the day, it will create the date into the days. Okay, then I'm creating a data frame, I'm giving the days as a date, and sales I'm passing over here as a column, and I'm giving the np.random int 100 500 800. What does it mean? It means that I'm asking numpy to create the integer between the 100 to 500 randomly for the 800 data points. That's all, and I'm setting the this index as a date. Now execute this. Once you execute this and try to run over here, you will see that you will have a date and sales, and on that we can perform the resampling. So I want to find out from these week wise sales. I want to find out from this week wise sales, guys. Week wise sales. So how will you find that? I'll write df dot resample, and over here you just pass w means week wise, okay, and dot sum. That's all. I think okay, it should be small, sum, and it will create the week wise your sales over here. So see, on 7th of January, this is the total sales. Then 14th of January, this is the total sales. Perfect. So this is called resampling, guys. Next, let's say that you want to find the week wise sales mean, max, and sum. So here you are, the sales data by week wise, their sum, mean, and max. So it is quite easy, I would say, right? Next, let's say that you want to find out the monthly wise sales. Monthly sales. So df dot resample, and over here you just pass m, and over here dot just, I think this will work. I forgot to write the dot sum over here. So this is the monthly wise sales you can get. So this is how you can use the resampling to find out the quarter wise, year wise, month wise, week wise sales. So now if I ask you to find the year wise sales, what you will do? Dot resample is sample, and over here you just pass y, and dot sum, and it will create the sales by year wise. Let me get the data over here. So the name of the data variable is patient data, right? So these are the data which we have used in all 4 videos, but today's video we are going to discuss about the date time function in pandas. But if you see this data, we don't have a date time function or date time columns over here. We have already only the year, but with that is not going to help out. So what we'll do, that we will create one separate data frame over here. There we'll have only date time columns, okay? And then I'll show you that what are the methods we can apply and what are the operation we can perform on the date time column. So what I'll do quickly, I'll create one over here dictionary where we'll have the timestamp. Under the timestamp we'll have the list of some date and time that is in a string. Okay, so I'll just execute this. After executing this, I need to convert that into a data frame. Before that, let's try to get this variable, what are the information are available in this. Perfect. So what I'll do over here, I'll just write date and time, or let's write the df better way. Df equal to, I'll write pd dot data frame. Perfect. And under this, I'll pass this data. As soon as you pass this, you will have the one column in this, that is date and time. Perfect. Now, if you check that df.info, if you do that, what you will have this, you will have the one column that is object, is nothing but the str. But whenever you want, let's say, what are the columns we have in this, or in this column, what are the fields are there? You can see there is a year, there is a month, there is a date, and there is a hours, minutes, and seconds. So if you want to perform some of the extraction on this columns, on this values or element, we need to convert that into date and time. But right now, if you see over here, it is in the it is in the string, right? So first, what are we going to do? That we're going to convert that into the date and time. So what I'll do, so df, and then over here I'll take this timestamp column name, I'll make this over here, and then equal to pd dot to date and time. Perfect. And after that, I'm going to make this pass this df of date and time. So what is going to do that? What is happening over here? See, there is a one function in the our pandas to date and time. What is the behavior of this function? So this function to date time will convert your date time column that is in object into the date time. So pd dot date time, and I'm passing df of date time, sorry, timestamp, that is my column name, and I'm saving that in my same folder, or if you want same column. So what if you want that, what we can do that, I can make a new column also. So I'll write over here, let's say new column, that is a date time. Perfect. So now again, what is happening over here, I'm creating one new column that is a date time, and I'm performing a to date time I would say operation on the existing column, which is in the string, that is as an object, but it has all the date time values. I hope you got the ideas, guys, right? So now I'll just execute this. Done. Now let's try to see what are the columns we have. We have a two column, timestamp and date time. Perfect. Now let's try to see the info of this. Means try to see the data types of this. So if you see the data type, the very first one, that is timestamp, is still the object, that is string, and date time is timestamp 64. Means this column timestamp is still a string, and this one is a date and time function, this date and time data type. So what are the operation we can perform on this? So very first one, what we'll do, that we already have a in this data, if you see we have a year, month, date and hours. So I'll try to extract the year first. So to get the year from the date time. So what I'll do for that, df of, let's say, year equal to df of date time date time dot dt dot year. So what is the meaning of dt over here? Dt is one of the, I would say, method which help to extract the year, month, hours and such kind of information from your date time columns. If you don't write this dt, it will not going to work. So dt is, I would say, the main player over here which help to extract the year, month, day, hours, is leap year and day of month, week of month, this kind of information try to extract from the date time columns. Perfect. Again, dt will work only with the column that is date and time, but if you perform on object, it will not going to work. Now let's try to execute this. Done. Now let's see the year has been extracted or not. So it has extracted the year successfully. Perfect. Now what is the next operation we can perform on that? So let's extract the month from it. Month from it. Now you will say that what is the use of extracting the year, month and all those things from the date time would say column. So let's say maybe there is a multiple year data over here. Along with that, there is some sales data, or some, let's say we have a patient data that we have discussed last video, right? Or last to last video as well. Then let's say you have a date and time function in date and time column in that, and you want to find out year wise what is the coverage amount. So what you will do, that from there you will extract the year, and then you will do the group by on the coverage amount and find the sum or mean, right? So that's why it is important sometime if you have a date time columns, how to extract the year, month, month name, all those. So that is what we are going to see in this video. Okay, so month from it, how will you extract the month from a date time? So I'll write over here df of month equal to, I'll write df of over here date and time. Perfect. Then dot dt dot year. If you just try to execute and see over here, you will have the month also over here. See, okay, sorry, I did a mistake, guys. I have mentioned over here year, it should be month. Now try to execute this and you will have a month in number. Now extract month name from the date time columns. So what you will do again, df of month name equal to df of date and time dot dt dot month name. So th month Now let's try to execute this, and you will see that there is a problem over here in the month name. Okay, month name is a function, so you have to execute like this. Perfect. So see, for the month 1, it is January, for 2, Feb, and for 6, June, and 12th is December. So this is how you can extract the month name also from here. Next, what I want to extract, that I want to extract the day name from the date time. So again, df of day name, okay, equal to, I'll write df of date and time, date and time dot dt dot, over here what I want the day name, so I'll write day and then name, and just this is also a function, so you need the parenthesis over here. Now shift and enter. After this, so now let's try to see that the name has been extracted of the day or not. So if you see over here, Wednesday, Sunday, Monday, and Wednesday. So day has been extracted from this. Now I want to extract the whether the day is weekdays or weekend. So that there is a two way of doing that. One is that you can use the custom function, and top of that you can use the apply, so to extract whether the day of the month is a weekend or weekdays. Other is that you can use directly a inbuilt function of dt, that is dt dot weekends, I think that is the function name, and from there you can get whether that day is a weekend or weekdays, but that will show you the boolean. So now let's see that how to extract or how to check. Let's say check day is weekday or weekend. So df of, let's say, weekend or is weekend. Okay, this is what we need to check that. So for that's what I'll do, equal to df, and over here just pass date time. Perfect. Dot dt dot day of week is greater than 4. As soon as you do this, you will have a over here true and false for is weekend. So Sunday is true. Why? Because it's a weekend. Perfect. What is the other way of doing this? The other way of doing this, you can use the custom function. So I'll write over here def is weekend, and over here you pass the entire year. Okay, and then over here, if df of, let's say you have the day of the week, right? So you write over here, if the day name, your day name is equal to Sunday, okay, or this day of this name is equal to Saturday. In that case, what you going to return? Return weekend. Perfect. Else you return over here weekdays. Weekday. That's all. I think it should be single red comma. Okay. Now execute this. After executing this, what you want to do, that you write over here df of, I'm going to create one more new column, is week end, and over here 2 I'll write. Why? Because I have already created one column. Two columns cannot be on the same name. Equal to df dot apply, and I'm passing over here is weekend is the name of my function. Once I'll execute this, what is the issue over here? Day name. Okay, so I have to pass over here comma axis. x is equal to 1, it means that you have to check on the horizontal, means x-axis, because all the columns are there itself. So now try to execute this. Again, there is a problem. They name. Okay, so what I'll do over here, I'll write df dot columns and try to execute this, and you have this day name. Try to copy this and paste over here. There is a mistake. Day name. Okay, I think this entire logic has been spoiled, so I'll write it again, guys. Okay, now try to execute this and execute this one. Done. Now let's try to see this. So over here, if you see, it's a weekdays. Why? Because it's a Wednesday. Sunday, it's a weekend. Again, Monday and Wednesday, it's a weekday. So this is how you can use the custom function also to get the whether the day is a weekend or weekdays. Perfect. After that, what is the next we want to find out is, I want to find out that quarter of the year. So I'll write over here quarter equal to df of date time dot dt dot quarter. Okay, just execute this. Now let's see that what are the quarters we have in the data. So these three comes under the quarter one. Why? Because January, February, March is in quarter one, then June in quarter two, and December in quarter four. Why do we need the quarter? Maybe you want to find out the quarter wise sales or quarter wise customer footprint in the store, or there can be XYZ I would say analysis based upon the quarter. Perfect. Next, I want to check that whether the year is a leap year or not. So how will you check that? Is, I'll write new column over here, is leap year. Okay, is leap year equal to df of is date time. Perfect. Dot dt dot is, there is a direct function, is leap year. Execute this. It means that 2025 is not a leap year. Perfect. Now we want to check the week number of the year. Week number of the year. So df of week number equal to df of date time and then dot dt dot iso this calendar and then dot week. Now try to execute this. Perfect. Now let's see that what we have a result. So if you see week number, so the 1st January 2025 is the week number of 1. Then if you see the 31st of December 2025, that is also showing the week number of 1. Why? Because maybe it has turned into the week 1 of the next year. So 30th of June 2025 is the week of 27. 31st of March, that is the 14th, week of 14th, right? And 23rd of February is the week of 8. So this is how you can calculate the week number of the year also. And from there, you can have several analyses like in which week, what is the my sales, what is the, I would say, moving average sales by week wise. So a lot of analysis can be done once you have this information from the timestamp data, right? Next, I want to extract the day of the year. So what I'll do, again, I'll create a new column, that is the day of year. Now we'll see what is the meaning of day of year. So that will be easy once I'll execute this to understand. Okay, date time dot dt dot day of year. This one, day of year. Now try to run this and see. So what are the data we have over here? So if you see the 1st of February 25 day of the year is 1, and 23rd of February 2025 we have a 54th day of the year. Similarly, 31st of December 2025 is the 365 days of the year. I hope you got that. What is the meaning of day of the year, right? Now we'll see how to extract hours, minutes, and second. So what we gonna do now, we're gonna create 3 new column that will based upon the hours, minutes, and seconds. So over here, df of hours equal to df of date and time dot dt dot hour. Okay, after that we're gonna write over here df of minutes equal to df of same date time dot dt dot minute. Okay, and then now next we're gonna see that df of second, and over here df of date time dot dt dot second. Perfect. So dt is the main player over here. From using that you can extract the year, month, hour, seconds, and everything, right? So I'm creating one new column that is hours, and from the date time using the dt I'm extracting the hours. Similar way I'm creating one new column that is the minutes, and using the dt I'm extracting the minutes from the date and time. So it is very important, guys. If you don't have hours, minutes, and seconds in the date time column, then you cannot perform this task. It is important that those data should be available. Perfect. Similarly, I have created one more column that is for seconds, and I'm extracting the second using the dt. Now execute one by one everything, and this one as well, and try to see that what are the data you have over here. So if you see, you have the hours, minutes, and second based upon this 10 hours, 30 minutes, 45 seconds. Guys, this is how you can extract the year, month, day, hours, seconds, is leap year, weekend, day of the year, day of the month from the timestamp data. So now we'll understand how to extract or how to extract or how to save the data into CSV and Excel. Perfect. So for that, what we're going to do that we have this df. So I want to save this df into the CSV. What I'll do for that? So it's easy, df.to, and you just write over here CSV, and then you pass over here name of the CSV. So you can do one thing over here. You can directly pass the CSV over here, or you can write over here file name equal to over here date dot CSV. Perfect. And then over here you just copy this, Control C, and paste it over here, and write over here index equal to false. Close this. What is the meaning of index equal to false? It means that this index 0, 1, 2, 3, 4 will not be extracted along with the data to the CSV. So now try to execute this. So as soon as you execute, it will get created in the existing folder where this IPynb file is running. So IPynb file is running in this Python for all YT playlist. So your this data CSV will in that folder only. So here you have all this. Now the question is, you want to create this in, let's say, some other place, download directory under new folder. So what you will do for that? How you can save the data in the desired location and desired folder. So for that you have to do workaround. What is the workaround? So I'll write over here dir path first. Before that you need to import OS. So I'll write over here import OS, and then you write over here dir path. Dir path equal to os dot path dot expand. You write the and user, this one. Okay, and then you pass the this symbol and then download with the backslash. Then you pass this symbol and then downloads, because I want to create a new folder into the download directory. Downloads. Perfect. And then close this. What is the meaning of this symbol over here? It means that it will try to merge, or it will try to add all the pre path of this download. So whatever the path exists before the download directory, it will try to add over here, because I have used the expand user and this symbol. Perfect. So if you want, you can just print this dir path also. Okay, dir path. Now I want to create the folder also. So folder name equal to, I'll write, let's say data yt. So I'll write the folder name data yt check list import. That is the name of my folder, which is going to create where in the download directory. After that, I want to create the folder path, because this folder name is there, but where you want to create this folder, we want to create this folder in download directory. So over here, just write os dot path dot join, and you pass over here this dir path comma folder name. Perfect. Now after that, let's print also this folder path. Now this folder is not available. We have to create this folder in this download directory. So for that, I'll write os dot make dirs, and over here you just pass the folder path. What is the meaning of this folder path? It means that this os.mkdir will try to create this folder and this given path. Okay, and then over here you pass exist okay equal to true. It means that if it is created, it is not going to override that. Perfect. Now I want to create the file name, that is again that data.csv. Okay, after that we have to combine the complete path of this file to including this folder. So what I need to do, that I need to create a path of this file in this folder. So what I'll do for this, I'll write over here file path equal to os.path.join, and over here you write folder path. Under this folder path, I want to create this file name. So this will give the complete path of your file. If you want, you can print also this file path. Okay, after that, now df dot to csv, and over here I'll pass this file path. Okay, it means that I have a file at this location, and then index equal to true. Sorry, false, not true. False. Close this. Now try to execute this one. See over here, from the very first print, it is giving you that see user Prashant and then downloads. I was not aware of that. What is the exact path of this download directories? For that, I use the expand user and this symbol. So with help of this, I am able to get the complete path of my downloads. Okay. After that, I created this folder, that is the data yt check list import. Okay. And then I want to and then what I have done is I created the complete path of this folder under the download directory. So if you see over here, this is the complete path of the folder. Okay. And after that, I have also created one data.csv, and that CSV I want to pass under this folder. So if you see this over here, C user Prashant download data yt check list import slash data.csv. So now the complete address of this file is under the download directory, under that folder I have created, which is this one. Inside that, this file is there, and in that file only I want to save the data. So I have just passed this file path over here, and df to csv has been converted. Now let's check that whether it is available or not. So what I'll do for this, I'll show you that over here. So let's see data yt checklist import, which is created now itself. And now let's try to see whether data is there or not. So just open this. So if you see that data is available over here, which is showing over here also. And if I open this in the Excel, you can see all the data over here, guys. Okay, so all the data is available over here. Perfect. Now, next is that how we can save the data into Excel. So what I'll do for that? So we have the patient data, right? Or let's say, let's have a new data set, and we'll see that how we can create those data into our Excel. So I'll create over here two data frame, df1 and df2. Perfect. See, and now I'll show you that what are the data we have into df1 and df2. Perfect. I want to save this data into the Excel, and two places. One in the existing folder, other where I have created this folder, in that folder. So what I'll do over here, that I will first take the writer equal to pd.excel writer, and over here we need to pass the path of the file also. So over here I'll write Excel path equal to, first I want to write over here, let's say product dot xlsx. So this is the extension of the Excel, xlsx, and over here you just pass the file Excel file path. Perfect. Now what I want to do, that df1 dot to Excel, and over here I'll write writer comma sheet name equal to product detail. So done, and then index equal to false. Okay, close this. Next I want to create the next, in the same Excel file, in the second sheet I want to pass the, sorry, I did a mistake. So df1 is the person details, right? So it should be person detail. Person details, then comma index equal to false. Perfect. Now in the same Excel, different sheet, another sheet, I want to save this df2 also. So what I'll do over here, df2 dot to Excel, and over here write comma sheet, sorry, I did a mistake over here, it should be writer, right? Writer comma sheet name equal to, over here you just write the product details, and comma index equal to false. Close this, and after that writer dot close, means close the file. Now execute this. Once you executed this one, you will see that one more this product Excel has been created, which is over here. Now you cannot open anyway. Okay, you cannot open this over here, but this is how you can create the Excel. Now what I'll do, that I want to create the same Excel in this folder, which is this one, folder file path under the download this folder I want to create. So what I'll do over here, I'll write over here Excel path equal to os dot path dot join, and I'll take this folder path from here because it is already created, so I don't want to create it again, guys. Okay, so if you want to create it again, then you have to follow the path from here to here. Okay, now let me do one thing. I'll copy this from here to here and I'll create the new folder, not the same folder. So let's remove this from here and write Excel data from pandas. Okay, so I'm creating the new folder now, Excel data from pandas, and then here it should be this one. I'll copy this from here, Control X, and paste it over here. Perfect. Now try to execute this. So at the end you have there is some mistake over here, I guess. You have the download directory, then from pandas you have already that, and then file path equal to, okay, you need this one, Excel file path over here. Close this and try to execute this. So it is created, right? Excel data file path equal to this, and then let's print the file path also. Print file path. Execute this. So you have this path over here. Now what I'll do that I'll use this file path from here to this one. Just remove this part from here and use over here. Now execute this. Done. Now go to the download directory and you will have one more over here, this Excel data from pandas. Open this and you have this product Excel. If you open this Excel, it will have two sheet. One sheet is the product person details. Under that you have a person detail over here, and the product detail where you have all this over here. Perfect, guys. So this is all about this video, and with this we have completed the pandas playlist. After that we'll start the NumPy, then we'll do end-to-end EDA and feature engineering using the pandas, NumPy, Matplotlib, and Seaborn. So probably we'll do that after completing the NumPy videos. So thank you so much. If you find this video interesting, don't forget to like, subscribe, and share, because it takes a lot of effort to make such kind of video, guys. Thank you so much. See you in the next video, guys.